Yeah, so hi everyone. This is exercise 13.5 of Thomas Calculus. I actually made a video on this like before, I don't know, I think some days ago, but then I deleted it because I thought it wasn't like up to the mark. But anyways, I'm taking this course multiple calculus, and so I'll have to read through all of this and solve all these problems. And it's all like just J stuff from what I remember. But yeah, okay, let's just get started through it. So basically, it's like my midterms are approaching, and I'm really low on like any practice. So I'm just gonna read through this stuff. Okay, let's get started. Okay, so next exercise 1 and 2, write acceleration in the form equal to tangential. Okay, and then without finding t and n. Sure. So how do we do that? Um, the tangential acceleration, and so you can always figure out the velocity vector. You can figure out the acceleration vector. What we want is the right this expression. mm, these two are like things you have to figure out in any case. Okay, cool. um, so the stuff along it, right, so it's just going to be like a vector dot v vector upon the magnitude of v. That is what your tangential acceleration is in the end. Or you could just say like a vector dot t, where t is just this quantity. I'm not so sure how I would be doing that without the interesting. mm, and it's like along v hat or something. Right. Without finding t and n, I don't know. I don't think it's possible. Well, in any case, like the normal acceleration would just be like subtract this and then there you go. But I think there was a formula somewhere. So the tangential acceleration is this. So it's just the derivative of the magnitude of the velocity. That's what the tangential acceleration is, which makes sense as well. Um, yeah, yeah, it does make sense, because if you think about it, what is this this stuff like d by dt of magnitude of v or something like that. That would just be well, if it, okay, this is another way to think about it. It's just v vector dot dv vector upon dt, and that upon the magnitude of v. So that just turns out to be like the derivative, so 1 upon magnitude of v of, well, v square, right? So yeah, okay, half of that obviously. So that would be the thing, which is just what, well, this comes outside and all that. So it's just like, it's just d magnitude of v upon dt. That's what the quantity is. Okay, so that's not a problem. What about the normal acceleration? So this is it's well known, like how much your speed changes. That's a tangential acceleration. What about the normal acceleration? So the normal acceleration is given as kappa v square, uh, right, where kappa is the curvature. So the curvature is, shit, I'm kind of forgetting. Okay, it's just t dot the magnitude of that upon v. That's what curvature is, if I remember this correctly. Yes. So dt upon ds, that's just this stuff. Yeah. Okay. Damn, I'm really forgetting all of this. But yes, so that's the curvature. I'm just gonna go through these formulas. So the tangential vector is just v upon the, okay, come on, that's pretty obvious. Then it's just t dot upon magnitude of t dot. That's what normal vector is. The v vector binomial vector is just like t cross n. The kappa thing is dt upon ds. The magnitude of that stuff, which you can just write as this. It's not a double dot. V cross a upon magnitude of v cubed, right? So why was that the case? Why is it v cross a? The magnitude of t dot, huh? We know that t dot is perpendicular to your. So you can actually just write what t is. T would just be the velocity vector upon the magnitude of velocity. So you want the magnitude of that, or okay, you want the derivative of that first. So that's what t dot is. So this is just going to be like acceleration vector upon the magnitude of velocity minus, so something upon velocity square, this stuff, and then d of v upon dt. But remember, this stuff we actually already know is just the tangential acceleration, which just happens to be a vector dot t dot, right? But then, yeah, okay, or dot t hat, I should say. Or you could rewrite this as velocity vector upon the magnitude of v, right? So this would just become a vector upon the magnitude of velocity minus a vector dot v vector upon the magnitude of velocity, and then velocity vector upon this guy squared. Yes, that's one way to think about it. And then you would want norm of this. Okay, that's just not gonna work, it seems. So this should be v cross a. Why should this be v cross a? The magnitude of that stuff is just v cross a upon v cubed. The v cube we can actually somehow manage. Not a big deal with that. This is upon the v thing in any case. Okay, cool. What about this? It's just this dot v square minus. Oh, I see where we're going with this. Okay, cool. So you can use the cross product formula, right? Yeah. So it's just v square. That's like v vector dot v vector, isn't it? So this would just be like the cross product. So the yeah. So just a cross v once again, I suppose. Isn't that right? Yeah, that isn't quite the thing. It should be v cross a cross v. Right, so that it's just like vv, that's v square times a minus a dot v. Okay, cool. And then all of that upon the magnitude of v cubed in v vector. That's what this is. Yeah, right. And that just turns out to be okay. So why did I put that over there? Sure, I put that. So it's just the thing is a cross v is perpendicular to velocity vector. So what actually happens is, since we're taking the magnitude, it's just going to be the speed upon the speed cubed, and then this stuff just a cross v, the magnitude of that. So this upon v, that just cancels this stuff. So that's what our quantity is, our t dot upon v stuff. So that's our kappa. Kappa is just v cross a upon v square. Well, it also in fact is the thing that t dot v square, that magnitude is actually the same thing as the a cross v magnitude, right? That's the main idea behind all of this, because obviously, like, yeah, that's pretty obvious. Yeah, cool. So this is cool. This is our usual thing. So yeah, okay. Now with that, I guess we can get started with all of this. What about the torsion? So the torsion is this stuff. It's x dot. Okay, cool. I actually should probably be doing this. So torsion is just, well, negative dv by d s or dt. I think it's dt, right? Okay, it's ds dot n. So the whole idea is that dv by ds, which is like the derivative of the binomial vector, binomial is like n cross t, that would just be like collinear to negative n. So it's going to be like negative kappa n or something like that. Yeah, and so you just take a dot product and that's what you get. And this is actually not, it's not like this won't happen. It's going to happen, because this is like d by ds of t cross n, but that's just like, so you can, yeah, right. So you can just write it as ts cross n plus t dot ns, but then ts you can read it as t dot times the velocity, the speed. Okay, and then this stuff, n dot speed, something like that. Yeah, because so it's upon, oh shit, it shouldn't be times speed, it should be upon speed, so speed inverse. Okay, cool. And so t dot is collinear with n, so this cancels, so you just get this stuff, right? So yeah, so just t cross n dot and then v inverse, right? And this turns out to be along negative n. Why was that? I kind of forgot it. Yeah, I kind of forgot that stuff. Hey, why was it along negative n of all things? I actually don't remember. So it's t over there and then that's n dot. That's perpendicular to t. Just think about it. So this is t, this would be n. We know that n is a unit vector, so the time derivative of that's going to be perpendicular to n. It can't be collinear to it, because then it would just mean like the magnitude should change. So then it's somewhere in this. Yes. Okay, so it's somewhere in that plane, right? And it's not like necessarily perpendicular to t. That's one thing we know. And you're taking a cross product of that with t. How would that make sense? Okay, so let's do the cross product. It's t cross, so n dot would be somewhere like that maybe, and then this would point in this direction or something, I suppose. That's how you define curvature. It shouldn't go along t dot n is n is should be like that. I get that it's along the n vector, but why should it be minus kappa n? Is kappa necessarily going to be positive? Why should it be along the minus n vector? Just trying to be universe. Think about it. V is a magnitude. Derivative of t cross n, that's what your B is. It's just, no, this doesn't make sense. Why should it be minus kappa and not like plus kappa? Sorry, minus tau and not plus tau. That's a very good question. I don't remember. I don't remember the reason for that. N dot. Okay. Let's say your, so okay, this is a dimension vector. Let's suppose it was changing like this, so that your n would be in this direction, right? Yeah. Wait a second. Your n is perpendicular, so okay, it should be going like this, in fact, for it to be like that. Okay, cool. And then, since that's happening, what's also, so your t is in this direction, and that's yes. So that's causing your n to be going up, because momentarily it should be going up, but that also causing your n to go like this, right? And so your n dot is in this direction, so it's in this direction that your n dot is. Yes, that's sure, that actually makes sense, because the way your t moves is precisely also how your n moves, I think. Yeah, so your n, hey, so what are you saying? You're saying that n dot is just it's something like this, huh? Okay, but momentarily it is the thing, and t is moving like that, so your n should be moving like this. That has to be right, because it's perpendicular to it. So yeah, so what does this mean? This just means that your n dot is in this direction, so then t cross n dot, shouldn't that just be 0? It should be, but it's not. Why isn't it 0? What the hell? I mean, it's like perpendicular, it's just somewhere over there. Oh, because if it was 0, it would just be planar quantity. Sure, that makes sense. So it's going up, but at the same time, what you also want to happen is that right, as it's going up, it's not exactly just perpendicular, but rather it's perpendicular and moving in some certain direction. So yeah, so you could be moving like this or like this, at the same time you also move like this. Okay, so what is happening is your n dot is moving in this direction, I suppose, so that your t plus, okay, in this direction. Yeah, then that would be that your binomial vector, which is t cross n, like this is moving in this direction and this is moving in that direction, so it's moving something like this, and that would be torsion, positive torsion. But yeah, I mean, in that case it is along negative n. Yes. Oof, this is just, I think it's just a convention. I mean, you just say it's negative and then you just move on. Can't be anything more, right? No, I don't think it can't be anything more. What about time derivative? It's the same as that, right? So it's just t dot cross n plus what? T cross n dot. Okay, and then t dot cross n is 0, so it's just t cross n dot. Yes, t cross n dot is along minus n. Why minus n? There has to be some reason. N dot. What is n dot? Oh, okay, I see. So n dot is right? N is just what? N is just t dot upon t. So yeah, okay, n dot would just be the time derivative of this stuff, so just dt dot upon, so the, yeah, okay, this is actually just that stuff, so it is t dot essentially, at least the, okay, is that the reason? And then upon that of t dot, I suppose. Sorry for all of this, it's supposed to be like the opposite thing. Why did I write it like that? So it's supposed to be t dot upon magnitude of t dot. Okay, cool. That actually makes sense. So taking a time derivative of that is t double dot upon t dot, okay, minus t dot upon magnitude of t dot square, and then dt dot upon dt, something like that. Okay, so this is our n dot, so you're doing a t cross n, right? But then, yeah, so t cross n is, right? Huh. So t cross t dot, that is okay. I mean, it's just a, right, that's fine. What about t cross t double dot? Well, t dot is not necessarily perpendicular or anything. Do we have any reason to say that t double dot is going to be something nice? No, we don't. We really just don't. Anyway, let's just try to figure out what t dot is. T dot is just what? How do I figure out what? I will have to write this in a different form. Okay. I just want to see the directions first. So this would be, well, t dot upon that. So it's the time derivative of the velocity vector upon the velocity, and then all of that upon the magnitude of t dot, right? And then minus t dot upon magnitude of t dot squared, then the time derivative of t dot, something like that. Yes, or you could just do it directly, but also works. So you know, just have t dot as a function of, yeah, so this is t dot, okay, so this would just be like the acceleration. I think we've done this somewhere, haven't we? Yes, we have. Anyway, acceleration upon the velocity minus, interesting. So your t double dot would just be, okay, no, so what you want is the n vector. So this is equivalent to just the acceleration minus v vector, and then dv vector upon dt, something like that. Okay, cool. So right, what is this? Oh, come on, think. I can't fit in the square root stuff, that doesn't make sense. Man of t dot, I'm really forgetting everything. Am I not? Normal expression is that. Why was it along minus n? I just don't remember. No, it's just v cross a squared. This is just stupid. This is just really stupid. What the? Why is this happening? Just forget anything like that. This doesn't make sense. It's just some arbitrary like notion. It might as well just have been plus kappa. It doesn't make any difference, I suppose. Yeah, that's how it should be. It's just minus kappa. That is how it is. I don't remember why it's minus kappa. I don't want to be doing all that calculation, but in any case, you just have t dot cross n plus n cross, sorry, plus t cross n dot. That's what this is. So this dotted with n would just mean, well, this would just become 0, sure. So it just becomes t cross n dot n, right? So it's something like t n dot and n, the triple product. So it's just, I suppose you can switch this, right? That's the way you would usually do stuff. And yeah, this is okay. We can just switch this stuff. So just negative over there. Oh, but it's negative already, right? Yeah. So you can use the negative to just break it inside. So it just becomes this stuff. Yes. You also have to divide by the velocity because it was upon s. So it's just this. So it's just t, and then n, and n dot, and that upon the velocity. So now n is just the same thing as t dot upon velocity. So what we can do is just t dot, and then 1 upon velocity squared, and then n dot. But then n dot we can kind of figure out. So n dot is just the derivative of, you know, t dot upon the magnitude of t dot. So that's just like, so you have something like this stuff, right? And then that's along t dot, so this won't really matter. And then other than that, you also have plus t double dot upon length of t dot, right? So you can just do that. You just have t double dot upon magnitude of t dot, right? That works. But we know this stuff. It's just v cross a squared. Yes. Yeah. So okay, this is this v cross a square, or is this just v cross a? I think this is just v cross a, right? I suppose yes. Yeah. What was the thing? I think it was like, why is this so confusing? Think, was there a square involved or not? So this would be like considering meter square squared, meter of 4, and this wouldn't be the thing, right? It's just meter square, because t doesn't have the meter thing inside of it, so those wouldn't be the same. So what should instead be the thing is that v dot a, so v cross a, that magnitude, that's actually equal to just v squared t dot magnitude. Yes, that's how it should be. So we want another one of these factors, so you have to convert to r. So the tangential vector is just like, it's just you know, the velocity vector upon the magnitude, so it's just upon v cubed t dot, then this stuff, so it's just velocity upon v cubed. So the scalar derivative, okay, that doesn't even matter because it just becomes 0. The other derivative is like acceleration upon the magnitude of velocity, so it just becomes power 4, and then you got acceleration with it. And then t double dot, yeah, that's something to be concerned about. So we know that t dot is just equal to like the acceleration upon the magnitude of velocity, that times of it's minus 0, so just v squared, right? Interesting. So it doesn't matter how many derivatives you take of this stuff, nothing really will happen. So t double dot is just like whatever is v triple dot, yeah, no, that's v double dot as well, moment of velocity, it's like the derivative of the acceleration, minus all of this stuff. Something is messed up with all of this. What exactly is going on? Something is missing. Oh, I see what's missing, because this should be squared. This should be squared. But n dot, this would be in the square, right? And yeah, so this just turns out to be like another v introduced in, and the acceleration derivative. So it's just r dot, r double dot, r triple dot upon v power 4 and d dot magnitude squared, which yes is just this stuff, v cross a squared. Okay, so far so good. We got all the formula derived. This is going okay. Okay, I think we can get started on this. Question 1. In exercise 1 to write acceleration in the form a equal to a dt plus a n without finding t and n. So just have r is this stuff. We just want to find velocity directly. So just velocity is equal to what? It's just minus a cosine comma a cosine comma t. Okay, so your magnetic velocity is just be like what? It's just, it's square root of a square something equals a square plus b square plus. So your magnet of velocity is constant. What does it mean? Is it constant? Yeah, it is. So then this is just 0. So at equal to 0. What about the an vector? An is, you had a formula for that. It's kappa magnet of v squared. I really just don't want to be doing it like this, but yeah, that's just how it is. So how do you find kappa? Kappa is just t dot magnitude upon. That's not gonna work, is it? Yeah, I was going to write this, but in hindsight, this just won't work. So you'll have to use the other kind of thing. Yeah. So the other formula for kappa, which is, okay, there's no, oh, there is. It's just v cross a. Sure. So it's just v cross a upon v of v cubed. Why is this cubed? Wait, what? Okay, so that times of v squared, right? So it's just this stuff. Okay, so just v cross a upon v. That's what the normal acceleration is. Okay, this is fine. This will about accelerations, and this should be easy. Acceleration is just fine. Just what, minus a cosine comma minus a sine comma 0. So now what we want is v cross a. So it's just gonna be like minus a sine a cosine b crossed with minus a cosine minus a sine and 0. So that's just going to be this and that. It's just 0 minus a is just like plus. So it's just b a sine minus a b cosine, and that cancels. So it's just minus a b cosine. Yes. And then the last one is just a square sine square plus a square cosine square, so just a square. Right, so this is what your v cross a is. So the magnitude of v cross a, that would just be, you take that a outside and then it just becomes square root of b square plus a square. Sure. So you just want magnitude of v plus a upon magnitude of v. Magnitude of v we already figured out, a square plus b square. So it's just a. A is our normal acceleration. Sure. I hope I'm doing something correct. I'm not just fumbling around. Is it the normal acceleration? I mean, there's a constant velocity in the k direction. We can completely discard that. That won't really matter. Your tangential acceleration is 0, so your normal acceleration is your acceleration itself, and your acceleration vector turns out to be this quantity. So yes, it is correct. So it's just 0 comma a. Question number 2. Sorry. So this is question number 1. In that you have 1. 2 is r of t is equal to 1 plus dt or whatever. So just find the velocity vector. The velocity vector is just 3 comma 1 comma minus 3. The acceleration vector is just like what? You take wait, what? Oh, that's gone. It's just 0. So acceleration is just 0. Oh, that's amazing. Yeah. So velocity vector is a constant. Okay, hope you don't have anything. So 0 comma 0. Move on. All of your like stuff is just gone in that case. Write a in the form of a to tm, okay, without finding tm, the usual stuff. So this is just a continuation of the previous one. So just 3 and sure. Okay, so these are actually just questions, isn't it? Question 1, question 2, question 3. Question 3 is r of t is this stuff. So the velocity vector just turns out to be 1 comma 2 comma 2t, and then the acceleration is just like what, 0 comma 0 comma so 2, right? So your v cross a is like what? So it's just gonna be 1 2 2t cross 0 0 2, which is what is got this is just 4 minus nothing, so it's 4. What about this? Is minus 2 and this stuff is just 0, right? So v cross a, your v, the magnitude of v is just the square root of 1 plus 4 is 5 plus 4 t square. Sure. So your kappa, you don't even need kappa, you just need an, right? So an would just be like 2 square root of 4 plus 1 is 5, so the square root of 5. upon square root of 5 plus 4t square. I suppose. Did I do the calculation correctly or not? 1 t plus at t equal to 1. We'll figure that out. No big deal. Tangential acceleration is just like what? It's just okay, so how do you find the tangential acceleration? It's just dv by dt, sure. So just take a time period of that, just 2 square root of 5 plus 4t square, and that 2 is gonna get cancelled anyway, just 8t. Not 8, just 4t, sorry. Right. That's what the tangential acceleration is. Sure. So yeah, we just dv by dt, that's pretty much it. It is a tangential acceleration, isn't it? That was the formula, right? Not, yeah, it's not s over there. This is the thing. Okay, so tangential acceleration, we figured it out. So you want it equal to 1, put that in. This is 2 square root of 5 upon 5 plus 4 is 3. Okay, so it's like 4 upon 3 over there. So you got a and 80. So 80 is 4 by 3, and an is 2 square root 5 by 3. I really don't know if these are actually correct answers, but I'll just keep going. Question number 4. Question number 4 is r of t equal to t cosine and whatever stuff. So just take a derivative. B is just like what? Well, so it's tc and ts and then t square. So just like c comma. Just take a derivative directly. Just c and then minus st. C minus st. And then we just have sine st cosine comma and then just 2t over there like that. It's an acceleration vectorization, just like minus s and then just keep going. Minus s and minus, so just minus 2s minus cosine t. Cosine is 2 cosine minus sine t and then 2. That's the acceleration vector. Okay, so now you just need v plus a. So v is just this, c minus st s plus dc. There's going to be some time to be doing this. Yeah, the acceleration didn't turn out to be nice for some reason. Yeah, it's just fine. This is not a big deal. It's negative sign here, isn't it? It's okay. That's just how it is. It's not a big deal. Okay. And then you got 2t. Then that crossed with negative 2 sine minus cosine t and then 2 cosine minus sine t and 2. So that would be what? You just have, suppose if this cross that, so this is going to be like what? 2 sine plus 2 cosine t minus, that's minus 4. Okay, minus 4 cosine t plus 2 sine t. This is what t squared actually. Okay, something is going wrong with all of this. Oh, okay, you can actually directly do this stuff without having to rely on it. So you can just figure out what it is like at t equal to 0. So that would just turn out to be, so cosine at 0 is 1 comma 0 comma 0, and that would just be 0 comma 2 comma 2, right? Yeah, this is okay. So your v cross a will now just be okay. Keep going. So you got your an is just going to be 2 square root of 2, and your tangential, that's going to be the derivative of the magnitude of the velocity. You really have to figure that out, huh? Okay, just have to do it. So the velocity is like what, square root of square that, so it's just c square minus 2s ct plus s square t square plus s square plus 2s ct plus c square t square, and then what the hell is this? This 4t square. Cancels, so just have 1 plus t square plus 4t square, which is equal to 8, right? 4t square, huh? You can't do that unfortunately, but yeah, it's okay. This is your magna velocity. Okay, but this isn't good. Yeah, it is certainly 4t square. Sure. Yeah, that's just how it is. Ah, okay. Okay, this isn't going good. This isn't going good. There's a 2t involved. Yes, there is. Fine, this is what the velocity is. Sure, so just do a sanity check. Yeah, the sanity check works. So the derivative would just be like, hey, that's squared, isn't it? Okay, so just 1 plus 5t squared. This is only 1 plus 5t squared. And it's like 5, and then 2 then comes out to just 5t. So at t equal to 0, it's just a 0. It's equal to 0. Sure. So what is this going to attention is just 0. Okay. Okay, next question. Question 5 is once again the same stuff. RT equal to this. So you just figure out the velocity and acceleration. The velocity is just going to be like 2t comma 1 plus, sure, so just 1 plus t square, and then we just have 1 minus t square. Okay, whatever the acceleration just turns out to be 2 comma 2t comma minus 2t. Magna velocity, that's just going to be square root of squared that, so it's just like 1 plus 2t square plus t power 4 plus. Okay, so just 2 times of that is like 2 times of that. Sure. Okay, just cancel all of that stuff. This is square root of 2 plus 2t power 4 plus 4t square. So this is going to be like what? Square root of 2 comes outside, and then you just have 1 plus t power 4 plus 2t square, just like what? This is square, so just like this stuff. Okay, amazing. So you got the velocity, so just dE by dt. That's going to be like what? So start with square root of 2t. So at t equal to 0, so that just when t is equal to 0, your v cross a. So v at 0 is just going to be 0 comma 1 comma 1, and then acceleration is also going to be like what? It's just going to be 2 comma 0 comma 0. Okay, amazing. So it's just like what, 2, and then I hat cross j hat just becomes k hat, and then so shit, it doesn't really matter, but whatever. So it's k hat, and then yeah, this just becomes minus, so it's just minus of I hat cross k is minus j hat, I suppose. Okay, so this is like what, 2 square root of 2 is the magnitude of this stuff, and then that upon the velocity when you just square root of 2, so just 2. So that's the thing. So the initial acceleration is just 0, and then normal acceleration is square root of 2. No, not square root of 2, just 2. Okay, next. Really hope what I'm doing is correct. So r of t equal to e power t cosine t plus e power t sine t plus square root of 2 e power t. T equal to 0, so the derivative is just velocity, that's equal to 1. So it's just, you can just take the e power t directly, so just becomes e power, yes, so it's just e power cosine sine square root of 2, and the other stuff is like inside the e power t you can take a derivative, so it's e power t, and then it's got minus sine comma cosine comma 0. That's velocity, just like e power t is just c minus s comma s plus c comma square root of 2. So your acceleration will just be e power t by distance, and the same stuff, so it's just acceleration plus c of 2 plus minus s comma, okay, whatever this is, c minus s square root of 2. No, not the square root of 2, just 0 over there. Yes, that's just way the way. That's just how the world works, it seems. Signals minor of v, right? So it's kappa v square, and for kappa you just have, wait, for kappa you have cube or what? You have a cube. Okay, fine, not a big deal. Just remember it. Okay, sure. So this just comes out to be, well, minus 2 sine comma 2 cosine comma square root of 2. Okay. Your magnitude of velocity is just equal to e power t, so your tangential acceleration is also just e power t, so that at t equal to 0 is just 1, and your normal acceleration is, so the velocity just turns out to be, yeah, it's not just e power t, okay, wait, it's e power t square root of e power c square, which is 2. 2 plus 2 is 4, so square of that is 2, so that types of 2, sure, so it's actually 2, okay, 2 comma the normal acceleration will just be, the e power t just is 1, sure, this quantity just turns out to be 1 comma 1 comma square root of 2, and acceleration quantity just turns out to be 0 comma 2 comma square root of 2. Okay, amazing. So your v cross a, the data upon magnitude of v just means you can make it this into a unit vector. That is only 1 by 2 over there, so just 1 by 2 and then this stuff 1 1 square root of 2 crossed with, so you can just take that 2 outside, or you just take a square root of 2 outside, just square root of 2 upon that, and then it is just this stuff. Let's see, so first we just got this, it's 1 minus of 2, I suppose, minus 1, and this one over there, square root of 2 over there, sure. Okay, whatever, so what we just want is the magnitude of this, so it's 2 upon square root of 2, which is just square root of 2, yes, I hope that's correct. Yeah, I guess so, it must be. So the tangential acceleration is in fact just this stuff, it turns out. So just subtract that out, it's just minus 1 comma 1 comma 0, and then the, yeah, okay, it actually does work out. Next, the main concern is, I'm not sure if I'm doing the correct thing, but anyway, finding the t and b frame in exercises, so when you find r, t and b given value of t, then find the equation for the oscillating normal and rectifying planes at the value of t. Okay, so r of t is cosine whatever, so I just want to find, okay, so r we already have, the t thing we can figure out, and we can figure out b as well for the value of t, then find the equations for the oscillating normal and rectifying planes of the curve. Okay, it shouldn't be so hard, so let's do this. So r is given as c comma s comma minus, so actually, yeah, it's a velocity vector, the velocity vector will just be minus s comma c comma 0, so just 0, which, so it's already unit vector, so it's also like tangential vector. Okay, so your normal vector will just be like t dot, right, upon the velocity, which, yeah, right, it's just no, it's t dot normalized, right, so you can actually just figure out what t dot is. So t dot would just be, take a derivative of that, just cosine comma minus sine comma 0, which, hey, that's also normal vector, so it's also equal to n, it's a unit vector. Okay, and what else did we want? The binomial vector, so it's just t cross n, so it's this cross that, so just minus cs 0 crossed with minus c minus s 0. So you know these two are just perpendicular to each other, you can just see it, it's going to be across the k hat thing, so yeah, right, it's going to be 0 0, because cancels, sure, and this is going to be 1. Okay, finally it is 1, what does it mean? It doesn't change, so your torsion is 0. Okay, we don't actually have to figure that out, but yeah, so this question is done. Okay, cool. Next, this was what, 7th, question 8th. Question 8th is r of t equal to this stuff. Once again the same stuff, so just find the so we want to be doing this at t equal to pi by 4. This will just be 1 by square root of 6, maybe 1 square root of 2, 1 square root of 2, comma 0, maybe 1 square root of 2, comma maybe 1 square root of 2, comma 0. Yeah, binary vector is just that stuff, so it doesn't really matter. Okay, so 8th question is r is this. Sure, so velocity vector is just what? Velocity vector is just minus sine, comma cosine, comma 1. Okay, this is going to be slightly different. So your t is 1 by square root of 2. Okay, so your t dot would just be your normal vector would just be minus cosine, comma minus sine. Right. So binary vector would just be this crossed with that. And yeah, okay, we also have a 1 over there, so you can't just be doing it like that. But yeah, it's just going to be like 1 by square root of 2. So you can actually figure this out, right? It's at t equal to 0. Right. So it's at t equal to 0, it's just going to be 1 by square root of 2, 0, comma 1, comma 1. And this will be t equal to 0. That's just cancelled, so it's just 0. This thing is minus 1. And yeah, this thing is 1. Okay. So you got a binary vector, so just 0, minus 1, 1. Okay, amazing. What else do you want to find? Nothing. Wait this down. Question 9. Question 9 is, so I need more space on it. Question number 9 is, okay, so okay, now you want to find t n kappa. It says 13 to 14. What 13 to 14? Oh, okay, section 13.4. Sure. Now in these exercises, you want to find d and tau for these space curves. So binomial vector and the tau thing. So you can actually just do the whole thing again, I suppose, because so they are thinking that we already had t and n, so now you can do these, but it doesn't really matter. Let's do it like straight up. Okay. So 9th question, let's go. R is this stuff, so velocity is what? Velocity is just 3 cosine, comma minus 3 sine, comma 4. Okay. So your, hey, so you don't want the acceleration, do you? No, you don't. Okay, so what you want is the b vector. So you know that b is just minus kappa n. So if you can figure out n, you already know what kappa is. Sorry, minus tau. If you can figure that out, you will be pretty much done, isn't it? Yes. Let's start it with it. Okay. Sorry, this is minus tau n, and then you take a dot product with minus n, and then you get tau. So if we can figure out, oh wait, you don't want to find tau actually, you just want to, no, you do want to find tau. Sure. I guess we just have to be doing the whole calculation. It's not a big deal. What are we going to do? I mean, you can easily find tau just like that. The binomial vector is slightly difficult, I suppose. Can you figure out binomial vector just like that? It's defined as t plus n, but that's not the only way to calculate it, is it? No, it's not. Oh, come on. Just wait a second. So t cross n is, it's like t dot. Let's see. So the cross product really doesn't matter because, okay, why isn't it working? What happened to screen copy? Okay, this is bad. This isn't supposed to happen. Okay, my USB cable got disconnected, that's what. And now it's connected again. Just a second. Okay, this is amazing. Yeah, so there's no formula for B. We'll have to figure out everything from scratch, right? Or we could make a formula. So you know that B is just, so it's T cross N, and that's like what, P cross, so N is just T dot upon N of T dot, pretty much. So what is the derivative of T? Okay, but T dot, okay, just think about it like this. Can you do it directly with the velocity? That's the, yeah, that's the idea. Okay, cross the time derivative of this stuff is just V cross on the magnitude of T dot, which we'll figure out. That's not a big deal. This V cross on V. So the other part will take a time. That doesn't matter. So just acceleration upon unit of velocity upon unit of T dot. So you already know like where it will be pointing to. So you know that B is collinear to V cross A, right? I see. So you don't actually have to do all the computation. You just find what V cross A is, and that gives you your B. So all you have to do is just this stuff that gives you your kappa, which is also just the magnitude of B, right? So magnitude of B is, okay, it's not a magnitude of B, but rather, is it? No, you know you know what B hat is. Wait a second. It's T cross N. Oh, I see. So you can find B pretty easily. Your B is collinear to B plus N, it's a unit vector. So there you go. For B dot would be along N. You don't actually have to compute N. You can just find tau directly. Yes. It's V cross A upon V square, right? That's the formula. It's not. that was kappa. Sorry. This is kind of weird. It's T cross N. Sure. So that would just be R dot, R double dot, R triple dot on magnitude of V cross A square. So you would need this anyway for everything. So once you have V cross A, so V cross A, you compute. From that you can get kappa. Kappa is just the magnitude of V cross A upon magnitude of V cubed. You can get B. B is just V cross A upon magnitude of V cross A. You can also get tau. So tau is just this stuff. It's V dot. So V acceleration and then acceleration dotted. All of that upon, yeah, so just basically like V cross A dot, right? Eventually just rewrite that. So just V cross A dot, and that upon the magnitude of V cross A again, but squared. Okay, sure. This is very weird. Wait, what? Squared. Oh, I see. So you can just do this and then rewrite this whole thing as B dot A. Okay, I see. I never seen it like this before, but that's just how it is. Okay, so that's what. Interesting. It's B dot A dot. Yeah, I mean this makes sense, but I guess so. I guess this actually does make sense. Sure. Fine. So this is what we'll use all the time. So this is basically the thing that I'm just gonna keep this formula handy. Okay, so this was also negative. No, okay, that got cancelled just like that. Okay, this is cool. So this is what we'll use. Hey, okay, ninth was a different question. No, okay, ninth is also the same category. This is basically our formula sheet. Okay, let's go. Question number 9. What is this? So what's V? V is going to be 3 cosine comma minus 3 sine comma 4. Accelerations minus 3 sine comma minus 3 cosine comma 0. So here V cross A will be like what? So it's just you can take the 3 out. So it's just minus 3 and then it's just 3 cosine minus 3 sine 4. That crossed with this sine minus 3 cosine comma 0. This implies magnetic velocity is just going to be 5. Pretty easy to see that. This is like tangential acceleration like 0 and all that stuff. So it's just what? Wait. If it tangential acceleration, no, that doesn't really matter. That doesn't really matter, does it? Speed and then d dot. No, probably doesn't. I'm just gonna keep going. So this is, yeah, so you just got V cross A, that's what we really want. Anyway, so okay, nothing. It's just my roommate is dancing like crazy. Anyway, minus 4 cosine, and then this is 4 sine, and this stuff is 3 cosine square. What? Let's see, something just like 3. Okay. That's your V cross A. The magnitude of V cross A is just, you can just get the binomial vector directly, I suppose. Just to get the thing, in fact, you can just do it directly. Just like 3 times of the magnitude of this stuff is just 5. So it's just 15. So what do you have? You have your binomial vector as just V cross A upon magnitude, which turns out to be negative 1 by 5 times all of that. So you just say 1 by 5, and then you got 4 cosine comma minus 4 sine comma negative 3. And your tau thing is just V cross A magnitude. It's like 15 upon no wait, that's kappa, sorry. So tau thing is just like r dot, so just binomial vector that dotted with a dot, so that's just going to be minus 3 times of cosine comma minus sine 0. Yes, yeah, so the magnitude of that stuff, I mean, okay, come on, what's the magnitude? It's just dot product upon the velocity cubed, I think, or is it square? So for kappa it's cubed. For so it's not even that, it's actually like V cross A square, if I remember correctly. Yes, that was the thing. So we already got that, V cross A square, so that magnitude is 15, so just like 15 square. Oh, but we dissolved one of them in the B vector, right? So it's just 15 basically. So this is going to be the thing, so this just becomes 1 by 5. This is like 1 by 25. And then this is negative, and then it's just minus 4 cosine square plus, so just minus of this, so 4 sine square, and then that thing just cancels itself, so it's just like this, so it's just negative 4. It's just minus 4.25, that's a tau. तो डाउनलोड फॉर्मेट क्या था? This is okay. So you got to be plus A. दोनों PDF क्योंकि दोनों मुझे मिल तो गए थे, एक सीरीज डाउनलोड फॉर्मेट एक्चुअली एक PDF उसका पता नहीं, मैं ऑनलाइन ही पढ़ा, डाउनलोड नहीं करी. ओके, अभी क्या है? यूजुअली क्या होता है, ऑल्टरनेट वेक्टर्स होते हैं हमारे, इवन ऑड इवन ऑड. Tau was just negative 4 by 25. So this actually works. Okay, question 9 is done. Question 10. Question 10 is r of t is cosine t plus t sine t. That's the usual stuff. So just velocity is what? Velocity is minus sine plus, and that's sine, that cancels, so just t. cosine, t cosine, comma, the same stuff over there. It's just cosine, cosine cancels, so it's sine, comma t, so it's just t sine, and then this thing is 0. This is looking amazing. This acceleration is like that. I think this is going great so far. So this is going to be like cosine minus sine t, comma, sine plus cosine t, comma 0. This is going to be like k hat. You can just say that directly. Your binomial vector is pointing in the same direction, so also it's just like the torsion is 0. So b is just k hat directly, so the tau is just 0. Sure, that actually makes sense. Next, what else do we want to find? B, tau, and that's it. So just move on. So yeah, binomial vector is just a unit vector, so makes sense. R is this stuff, is e power t, so the usual stuff. You just like take a derivative of 0, so you can just kind of make this go back to 2D essentially. Okay, so once again the binomial vector is going to be, oh come on, so if it's planar, your binomial vector is going to be just in the k hat direction. So you can do this without even actually calculating anything, like just straight up say that it's planar, so it's k hat and then tau is 0. So if this was a multiple choice question or some sort of a question where I don't have to show the work, I would just say it's k hat and 0. 12th, so the velocity is there, the acceleration not so much, so okay, it still has some quantity. Fine, we'll have to do the usual thing. So velocity is what? Ooh, 2t, are you serious? Fine, just do the thing. So just 12 sine 2t and then 12, okay, so we want to take a derivative, sorry, cosine 2t and then minus 12 sine 2t, and that stuff is just 5. So your magnitude of velocity is 13. So your acceleration is like what? Acceleration is just 24, and that thing is 0. So this will just be like minus 24, yes, minus, and then you got minus sine 2t, comma, cosine 2t and all that stuff. Okay, this is 0. Okay, cool. So we want v cross a. Yeah. So binomial vector dotted with acceleration dot. You will have to do stuff. Okay, so this is your acceleration. You have all of this. What's your a dot? That's important. It will just be, we'll just take that out. So just 48, comma. Okay, so why did I get a minus outside? Something must have gone really wrong. Okay, plus minus isn't supposed to be there. But yeah, so it's 48 comma minus cosine 2t, comma sine 2t, because the minus comes inside. Okay. So what we want is the binomial vector first. So it's just going to be like v cross a basically. We just have to figure that out. So v cross a, that's going to be, okay, so for tau it's essentially just the binomial vector, right? No, you have to figure out what v cross a is because you need a square. Sure, so just do it, the usual thing. So it's minus 24 and then you got 12c minus 12s, 5, and that crossed with sine, cosine and 0, which turns out to be minus 24, and then this stuff, so it's just that's 0, and then you got minus 5 cosine. This is 5, this thing is sine over there, so it's just 5 sine, and then the thing is 0, and for this it's 12c square plus 12s square, which is 12. So v cross a, so magnitude of this one, magnitude of that, that's just this stuff, because a is this. Is this correct firstly? Yes, it's correct. So just gonna write that it's minus 24. Let me just write it like that. directly. So it's 24, and then you got 5 cosine comma minus 5 sine, and then minus 12. Okay, amazing. So you got your b cross a. You just normalize that to get the b vector, right? It's collinear to that and all. So it's just b is, so this has magnitude what, 13, just 1 by 13. Hey, so do you need the b cross a, or do you just need the b? You need the b oh, so you dissolve it of that, right? Yeah, so you need the b cross a magnitude only, essentially. That would just be like 24 times 30. So yeah, 24 times 13. So your tau we can figure out, but first for b thing, b is just 1 by 13, and then 5c minus 5s minus 12. Sure. So then it's b dotted with a dot, so it's, oh, what the, so it's minus 5c squared. Why is everything negative suddenly? Yeah, just what happened? Your tau is negative. Should that ever be happening? I mean, it can happen. It's not like it can't happen. It's no such restriction. So tau is just negative. What's the big deal? Right? Yeah, you just have a negative version. Not a big deal at all. So your tau would just be, so you got 5, hey, what, a dot, yeah, so minus 5 cosine square, it's 5 sine square, just minus 5 essentially. It's minus 48 times 5, that upon 13, and that upon the magnitude of b plus a, which is 24 times 13. So that cancels with this, it's just 2, so it's just minus 10, so it's minus 10 upon 169. I really hope what I'm doing is actually correct, not just some random stuff, but let's move on. Question 13 is r is this stuff, so your velocity will just be, do I even need to do anything? We know that it's going to be 0 comma k hat, so it's just k hat comma 0, because come on, it's a planar thing. So question 14. Question 14 is, oh, this was question 14. Oh, in fact, for question 13 and question 14, both is just the same stuff, is k hat comma 0. Question 15, so it's planar, the same. It's k hat comma 0. For question 16, it's, okay, so you have something at least, so velocity is what. So this thing is, so I'm gonna use s and c for sin h and cosine h, although I usually use it for like sine and cosine. So just have sine comma minus cosine comma 1 acceleration. So remember, what you have is like c square minus s square equal to 1 now. Okay, so your acceleration is just cosine comma minus sine comma 0. Okay, cool. So v plus a would just be, let's see, so it's s minus c1 that crossed with c minus s0, which is, so minus s square plus c square, which is 1, and then, oh, so that was for this coordinate, sorry for that. So for this you just have 0, and then so it's just s, then for this one you just have c. Sure, so that's v plus a. So your binomial vector would just be like, okay, so it's at some particular t. No, you don't have that at any particular t. That's just how it is. Sure. So yeah, just figure out the, so things has wrong. Okay, this is amazing. So figure out the magnitude, all that stuff. Just be like square root of sin x square cosine x square plus 1. So sin x square plus 1 is just cosine x square, so it's like 2 cosine square, so just square root of 2c. Okay. Your binomial vector would just be like what? It would just be tan h, which is s by c, comma 1, comma 1 by cosine or something like that. Sure. So what is your a dot? It's important. So a dot is, yeah, I guess that actually works. So a dot is minus, not minus, it's not cosine, it's cosine h. So it's sine comma minus cosine comma 0. So what we want to do is just take a dot product of this with p and then divide by this quantity. So that will be, hey, so you should also have a square root of 2, just kind of a reminder. It's a square root of 2c squared, essentially just like a 2c squared, and then just take a dot product with the normal stuff, this quantity. So that's going to be like h squared minus c squared plus 1, which is, oh, that's just 0. So somehow your tau is just 0. Why is it somehow just 0? That's not quite how I thought it would be. Are we sure this is the correct thing to do? Never mind all that. No, it's not. It's not. So your A is this. Sorry, this is not. So A dot is this, and your V cross A stuff, which is what we got stuff from, is that it's not 0. It's s squared minus c squared, which is just negative 1. So negative 1 upon 2c squared. That's what the tau thing is. I guess. Yeah, I mean, that makes sense. Yeah, sure, that actually does make sense. That just like the direction of my vector, and then this makes sense. Okay, so your tau is just minus 1 upon 2c squared. And we got a binary vector, and it's not a big deal at all. Okay, next question, question 17. Question 17 is this. Okay, this is question 17. The speedometer of a car reaches steady 35 something something something. Could this be accelerating? Yes. Just this is your car. It's moving like that. Come on, basic questions. Question number 18. Can anything be said to be about the acceleration of a particle that is moving at a constant speed? About the acceleration of a particle that is moving at a constant speed. Its tangential acceleration is 0, that's one thing. Question number 19. Its acceleration is just a normal acceleration. Can anything be said about the speed of the particle whose acceleration is always orthogonal to its velocity? Its speed is constant. Wait. It's moving at a constant speed. Okay. And this is the speed of the particle. So acceleration is always orthogonal. So it's normal velocity. Sure. So which is to say that the speed is constant. Okay. Question number 20. Question number 20 is an object of mass m travels along the parabola y equal to x square with a constant speed of something. What is the force on the object due to its acceleration at, so its speed is constant. Okay, so it's basically a unit speed parameterization. Sure. Its acceleration at 0 0 at, okay, write your answers in terms of I and q. So remember your kappa thing. Kappa is just magnitude of v cross a upon what? I'm forgetting stuff. Am I not? Yes, I am. Okay, or the magnitude of v cubed, and then your normal acceleration is just what? It's just the same stuff actually. This, so basically, like your kappa is just the normal acceleration about v square. So if you figure out what your kappa is, actually, you know what? You just figure out what v cross a is. You can figure out what the normal acceleration is. Oh, you just need the kappa in the first place, right? Wait a second. Kappa you can actually just figure out. I mean, it's just the curvature. So yeah, the curvature shouldn't be so hard. You have the formula for that. You can figure out the curvature, and then from that you can figure out the normal acceleration directly. So what is the force on the object due to its acceleration? at 0 0. So you know that the tangential change is 0 because the speed is constant, so the normal acceleration is the only force, and we can figure out what its quantity is in terms of I and J. So you know that the speed of the velocity, like what it is going to be. So it is acceleration at 0 0 and at square root of 2 and 2. Okay, sure. So you just need the normal direction and then you have everything, because you can easily figure out this stuff. Okay, cool. Or you can use a airspace parameterization, I mean, if that makes any sense. I would not want to be doing that though. Still, if I had to do it, it would be something like 80 square comma 280 is the parameterization using stuff. So, or you know, since this is y equal to x square, you could just use this parameterization t comma t square. So then the velocity is something like 1 comma 2t. The magnitude of that is just square root of 1 plus 4t square, and that times of dt, integration of that from 0 to some t. That's how it is. I'm sure I won't be doing that. Just 4t square, huh? Angle of velocity, yes, that's what your s quantity is. Not worth it. I don't think it's worth to be doing this stuff. Although it shouldn't be so hard. Just do t equal to tan theta and then you get something like secant theta or maybe the secant cube theta. No, just no. This isn't the way to be doing it. Right. Acceleration at 0 0 and right. Sure. So it's not a big deal. Just find kappa. Kappa is the curvature, so just y double dash upon the 3 by 2 power of 1 plus y dash squared. Yeah, the usual stuff. Right. Okay, so what is that? So since it's y equal to x square, it's just gonna be like, wait, what? Double dash, huh? So it's 2x and then okay, it's just 2 upon 1 plus 2x is like 1 plus 4x square of 3 by 2. Okay, that's what your kappa is. So the normal expression is like v square times of that. So the v, you know, it's just 10. So it's just square. It's like 200 upon the square square. But what's the normal vector, right? So your tangential vector is along this direction, just like for every unit x increase, you have a y dash increase. Y dash just happens to be 2x. So yeah. It's in this direction, so the actual thing would be something like, you can forget all that. You can just say that normal vector is like collinear to this is minus 2x comma 1 upon square root of 4x plus 1. That makes sense. So it just be like an times n. That's the thing, I suppose. Yeah. So this one, this is the formula where your angle increases. So remember your kappa. This is the signed one actually. So it's defined as a d phi by ds, where your phi is like the angle that the tangent makes with the x-axis, or any line for that matter, the counterclockwise angle. So yeah, what you're saying is like your kappa is in this direction. So if this is positive, what it means is like it's curving upwards. So your normal is in this direction. Sure. So we just want it to be in this direction. So this makes sense because it's going in this and then that. Yeah, cool. And this stuff is like this. So just repeat it like that. It makes sense. It just times iota essentially. Yes. So yeah. So your acceleration vector would just be, because the tangent is just like 0. So it's just take a 3 by 2 power, multiply this stuff, you get 1 plus 4x per power, the square of that, and then you just have 200 and then minus 2x normal. That's your A vector, and that's what you want, right? What is the force due to the acceleration? So of m mass, so you know, you can just be putting some v squared stuff over there, so just do v squared times of m, something like that. Right? Solution. That's a unit vector, sure. Yeah, I mean like v squared by r equal to acceleration. So it makes sense that you would be having the v square kappa thing as your A. an is this. So you find kappa and this is your an. It's okay, it's okay, it's not a big deal. I think this is okay. So you got your acceleration, and yeah, this seems fine. Okay, cool. So this is your answer. No square root, actually, just 4x plus 1 square. That's the thing. So this vector at 0, right? It's 0, 0. That would just be like what? That would be the magnitude of v square, just that magnitude of v square, and then this would just be minus 0 comma 1. So this is 0 comma 1 upon 1 square, just 1. So it should just be like 2 v square j hat, which is, so what's v square? Just 100, so just 200 j hat. And then the acceleration at what? Square root of 2? That's gonna be 200, then you got minus 2, so just minus 2 square root of 2 comma 1, yeah, upon this thing squared, so just that's okay. 8 plus 1, 9, 9 squared, just like 81. That's the thing, which is minus 400 upon 81 square root of 2 I, and plus 200 upon 81 j. Yes. So once you have the accelerations, you can just easily figure out the mass and all. You can just figure out the forces. Question 21 is, show that kappa and tau are both 0 for this line. It's x plus 80. Okay, we got ct over there. For this, why would it be 0? It's just like from starting from a point, you're moving somewhere, right? Oh, okay, it's not somewhere. Okay, it's not a function, sorry, it's moving along a line, so obviously your torsion is 0. There's no curvature, no torsion. Makes sense. Shouldn't be hard. So it's just like v equal to what? V equal to a comma b comma c. That just means your acceleration is 0, right? So your v cross a is 0, which means your kappa, which is just v cross a upon v cubed, that thing is 0, and your tau, which is what's tau? It's more complicated than this. It's like b vector dotted with, okay, how do you find tau? Tau is like the derivative of b, that's going to be equal to negative, so you need the n vector and that stuff. So this is a velocity, which means your t is just some constant vector, so your n is not defined. Whoa, okay, your n is not defined. You don't actually have a binomial vector defined properly. You have your t dot 0, so how do you define your n? You can't. Since you can't, there's no point. How do you say that the torsion is 0 exactly if you can't define your t dot and n dot? A limiting case, maybe? I don't know. What did kappa is 0, sure. What about tau? Tau would be like, it's defined to be minus the derivative of binomial vector dot that. Okay. How do you define your n vector? I guess you just choose some arbitrary direction, just like that. So then your binomial vector is like constant, because you're choosing it to be arbitrary, and t is constant, n is constant, so d is constant. So dv by dt thing is 0. So what does it mean? Yeah, your d vector is also constant. In fact, the fact is, no matter how you choose your n, even if it's like varying or whatever, your binomial vector will always be like this. So this is your t, this thing is n, your d will be pointing like this. So your, as your n changes, your b changes, right? Yeah, it changes with the same quantity. Yes. So essentially what you have is like your b dot is just like t cross n dot, cool, but then that dotted with n, that's a problem because n dot is perpendicular to, hey, is that the thing? T cross n dot, something isn't making sense. It's just t cross n dot, sure. N dot, how does it n dot, is this in this direction? Sure, so if this direction, t cross that, it's already in this direction, which is minus n, okay. And yeah, so wait, but then it's not 0 in that case, is it? If you are actually changing it, no, it's not. Yeah, I mean the whole point was that d dot actually dictates how your n thing moves, and that actually dictates how your b thing moves. So if your t is a constant, then I guess you just have to say we define it to be 0. So it's done, I suppose. If t is a constant, okay, what about if t is a constant and n is actually varying, like it's just a really small force? Come on, this doesn't make any sense. Or you could just go this route, right? You could, okay, no, that doesn't work. Nope, nothing makes sense right now. This is just 0, you know that. But it's a planar motion. You have to define it to be 0 for it to be consistent with our whole theory. So that a moving particle will, so the first condition was that your kappa is not 0, right? For this to make any sense, but since it's already just that, yeah. So that a moving particle will move in a straight line if the normal component of its acceleration is 0. Yeah, I mean if the normal component is 0, what does that mean? That just means v cross a is 0. Right? Yeah. Because the normal component is just defined by that v cross a upon magma v. Or you could just say directly that this is happening. Which means that v is collinear to a, right? So what happens is something like your dv by dt is always just some minus straight line, huh? Is collinear to a, and this is actually gonna work. So dv by dt is just some minus, I mean it's acceleration obviously, but it's collinear to v. Acceleration is collinear to v. What does that mean? It's just like some minus f of t, some function that times of v vector, or v hat is more like it, but yeah. So you can actually split this stuff and say that okay, dx by dvx by, or you can just say vector over there, that also makes sense. That's just equal to minus f of t, and then vx, and then solving this you get the thing, right? Yeah. Think about it. So I suppose you can just take a cross product inside. I mean that would actually work. Then integrate into just like v vector and all that stuff. Yeah, it's not making sense. Just d square r by dt square is equal to minus. Okay, whatever. In a straight line, if it's accelerations, yes, we know it's gonna happen, but okay, whatever. Just move this. It's just vx is equal to what? So right, it's just like e power negative f of t plus some constant, right? So just that times of something, some ax. Right? Cool. Yeah, that actually makes sense. So what does this mean? What this means is, what the hell am I doing? Oh yeah, so rx, or the x component itself, that would just be like, so it's not just this, actually it's like integration of that, right? Okay, so your x component would just be like integrate that. So integration of e power negative f of t dt, all that stuff. And y components like b d, okay, y, some integral, whatever. But the important thing is, like, it's basically like this. It's g of t. It's the same function essentially, right? And obviously plus some constant. So these constants may be different, but these functions are the same. So that just means like your path is like a line, because as the g thing varies, your x, y, they go along a line. So not so bad, I suppose. The point always lies on some sort of a line. So okay, question 23. 23 is a sometimes shortcut to curvature. If you already know a n and v, then the formula, okay, gives the convenient way to calculate curvature. Sure, use it to find, oh okay, you already know normal. Find the curvature and radius of this curve. Okay, anything given, take an and b from example 1 and just calculate it directly. So it's this is what velocity is, just minus sign, and that sign cancels, just t cosine comma what's up? So yeah, v cross a is actually where a n is pointing to. Hey, but v cross a is also where b is pointing to. What the? Tangential gets cancelled. Oh, it's not where a n is pointing to. Sorry for that. It's related to magnitude, but not the direction. So, what is a n related to? I don't know. I don't care. Can you directly figure out its direction just like that? I doubt that. You can figure out the. It shouldn't be so hard though. You already have. You have your v hat and a hat, so this shouldn't be that hard. You just need a normal component. You figure out the. Yeah, that's just the usual stuff. The triple cross product, that's what you will have to do. But never mind all that. So just want what? Velocity is tc. What the hell? So just cosine cancels. So it's just sine. So it's just d sine. And then this stuff is just not there. Okay, so that's your velocity. The acceleration is something like this. It is cosine sine and then minus sine t plus cosine t. Okay, so you got your v and a for some t whatever. You want to figure out the normal acceleration, the speed. So this implies the limit of velocity is just equal to t. Okay, you can kind of figure out what your an is going to be. So an is just going to be like the limit of v. You just figure out what v cross a is first. So v cross a is just going to be like t, and then you got c cross s, and just 0 0 again. It's just a determinant, isn't it? Yeah, it sure is. So it's just t and then this determinant, just c minus st minus plus ct. So just like every other determinant, you can cancel this stuff out. Yes, so this becomes t square cs minus s and c, and that is a rotation matrix. So it's just t square. Okay, cool. Yeah, so that's what v cross a is, the magnitude at least. So okay, you actually have everything. So yeah, I mean your an would just be like t square by t, which would be t, and your rate of velocity would be t, and that implies your kappa is this times square. So it's just what, a n upon v square, so it's 1 by t. Makes sense. Sure, that makes sense. Yeah, okay, move on. So question 24. This will move to the next page. So question 24 is what can be said about the torsion of a smooth plane curve r of t equal to this stuff. Give reasons. It's going to be 0. That's the thing. My reason would be a velocity vector is some f dash t comma g dash of t comma 0, right? Your acceleration, I'm just going to derive this stuff directly. This acceleration is like f double dash of t and g double dash of t comma 0, and so that just never mind. I'm just going to say like your t is some function, so the t is just some capital F of t and g of t, right? Just some functions, we don't really care. And then t dot is just their derivatives. And that just means like your n vector is some like x of t, y of t stuff. I could use some other variables, a of t, b of t. So these do not even need to have any sort of relationship, because what happens is like t cross n, that will just be in the b direction, essentially. Yeah. So that will be like given by this stuff, I hat, j hat, k hat, and it's got f g 0 and then a b 0, which just happens to be this determinant f g a b that times of k hat. Yeah, but then we know that, so it's not supposed to be n, but magnitude of b equal to 1, which implies that this quantity should be 1, therefore b would just be k hat. So therefore the dv upon dt stuff would just be 0, which implies that your tau is 0, so its torsion is 0. So this is done, no big deal. Question 21, that was easy. So to question number 25. Differentiable curves with 0 torsion line planes. Okay, so that is sufficiently differentiable curve with 0 torsion. What do you mean sufficiently differentiable? What does that even mean? Lies in plane is a special case of the fact that a particle whose velocity remains perpendicular to a fixed vector moves in a plane perpendicular to c. A particle whose velocity remains perpendicular to a fixed vector, okay, moves in a plane perpendicular to c. Thus, this in turn can be viewed as the following results. Okay, start with so if v dot k, so even if like your so if h of t was some sort of a constant, then this would happen, right? So that r is 0 when t is 0. Look, you know what, I'm just gonna skip all of this bullshit. I'm just gonna do the main thing directly. So what we want to show is that 0 torsion implies that your plane is in a, so your curve is in a plane, right? Okay, so right, so essentially what you say is that your b vector is constant if your torsion is 0, right? So since tau is just negative, so we know that your b dot stuff, which is equal to negative tau n, right? I mean, it was dv by dt. I don't think it was, it is dv by ds, sorry for that, right? So it's not just this, it's actually like v tau this, in fact. Yes, that seems to be the case. Constant speed. It's okay, it's okay. It's not a big deal. It's just a direction. So it doesn't really matter. So I am vector is just that. we never actually calculated the binary vector using b dot in any case, so it doesn't really matter, right? Okay, but be careful. So b dot is just minus v tau n, right? It's a fact. Okay. Now the thing is, we are saying that if your torsion is 0, then this just means it's equal to 0. So that just means your b is some sort of a fixed vector. So b is constant. Moreover, it's like a unit vector. So whatever. So what is b? B is just t cross n. So this vector is constant, right? Yes. So this crossed with b would just be like 0. Sure, that's one way to think about it. But you also know that b is collinear to, so we can just write it like this then, which is equal to, yeah, that's not a good thing, is it? No, it's not. Crossed with b, if it is crossed with anything, it would just be like con, I suppose, time derivative of this stuff. No, that doesn't really matter. What I want to show is 0 torsion implies that stuff, right? It's in a plane. Okay, it's in a plane. So you know that both t and n are perpendicular to your b, right? So at any given point, what's happening is, this is your b vector, right? This is your point. You have some t like that, you have some n like that. So this is your plane. Okay. So this is perpendicular to both t and n at the same time. Yes. And your t is your velocity vector, right? So what does that mean? That your velocity vector is perpendicular to b at all points. So your v dot p is equal to 0, which is to say that your dr by dt dot b equal to 0. Because this is like pretty obvious, right? You just take a dot product of that to b, it has to be 0 because it is like, yeah, I mean, it's crossed, so it is perpendicular to t, literally, right? What I'm basically saying is that b dot t is equal to 0. It's true, obviously, right? Yeah, I mean, that's going to be 0, sure, obviously. So what does that mean? That just means like dr by dt b is equal to 0. So like integrate that. So just r dot b plus some constant, obviously, so plus some c dot, or I should say minus c dot b, that's equal to 0. So basically like r minus c, or you could just say r naught, that's a better way to think about it, r naught, and in terms of b, that's equal to 0. So that just means r is something like in a plane, essentially, right? Yes. So you have some binary vector, this is your r naught, and r is somewhere over there. This vector will always be in this plane. It's a plane, that's what this thing is. So there you go, you have just proven that 0 torsion implies a plane. So question number 25 is done. Question number 26. 26 is a formula that calculates tau from b and b. If we start with the definition, okay, so we want to arrive at this formula. Okay, so we write dB by ds as this stuff, no big shit, it's pretty normal, and tau is defined as this. Use the formula. Okay, so this formula is well known. Use the formula. So okay, it was dB by ds, now it's like minus 1 by v, and sure, to find the torsion of the helix in example 2. I won't do that because I don't want to go to example 2. And firstly, this is an inferior formula. I can just do the v cross a stuff, right? Yeah, I mean, just b is along v cross a, find the a dot, and be done with all of that, you know. So the only formula that I really care about is like v vector cross a vector, that dotted with a vector dot upon the magnitude of v vector plus a vector squared. That is it. That's what torsion is, right? That's the only formula I really care about. Okay, next is, so computerized question, we know how we're doing that. 13.6 is done. 13.7, this is practice exercises. There's quite a lot in this. Additional and advanced exercises. Okay, this is actually where I was getting some questions from, so I probably should be doing all of this. Technology application projects. Wait, this was 13 point. This is like orbits and stuff. I really have no idea what's going on. So should I be doing this stuff first? Okay, no, this is some data stuff which I'm not interested in. Anyway, 13th practice questions. That orbit stuff wasn't done, so I've not completed. Chapter 13 practice questions. So, sketch the velocity, acceleration vectors. What do you mean graph the curves? Oh God. Without finding T and N, and find the value of kappa at given value. So once again, our tangential extension is like d small v upon dt, all that stuff. A normal is just the usual thing, just b cross a magnitude upon the rate of v, just that's it. Yeah. Also find the value of kappa and just v squared at the point. Okay, the position of a particle in the plane at time is find the particle's highest speed, all that stuff. This doesn't look so complicated at all. So first is all just like graphing stuff. Should I be doing this? Nah, I'm just gonna figure out the AT, AN and the kappa thing. So first is R, is this stuff, so the velocity would just be like minus 4 sine, comma, square root of 2 cosine, comma, nothing, so just that. The acceleration is just like what? Acceleration is minus 4 cosine, comma, minus 2, minus square root of 2 sine. Okay, no big deal. So v cross a, the magnitude of that, I'm just doing it directly, it's the determinant, so it's just going to be like, so it's just minus is plus, so it's just 4 square root of 2 sine square, and then plus 4 square root of 2 cosine square, just 4 square root of 2 essentially. This is 4 square root of 2, and then the magnitude of velocity, that's just going to be like square root of, ooh, that's some problematic, so 16 sine square plus 2 cosine square, huh? Distance, that's just like what? That's just equal to square root of 2 plus 14 sine square or something like that. Yes, of that sort. Okay, so we want this at t equal to 0 and at pi by 4. So t equal to 0, we just have like magnitude of velocity is just square root of 2, and magnitude of v cross a is just 4 square root of 2. So basically your an would just be, also you also want the what do we call it, that stuff, don't we? Yeah, the tangential acceleration. So equal to dot d stuff, okay, let's not do that. So v you actually have as a function, so you can just take a derivative, yeah, I suppose. So you just have d small v upon dt, that's going to be equal to, yeah, that's the tangential acceleration. So this is going to be like what? So I suppose we can take the square root of 2 out. Yes. Right, times cosine. That makes sense. So it's 7s square root of 2 times. Right. Okay, so we got that, no big deal. Time to put these values inside them. So just p equal to 0, p equal to 0. So this is like what? This is just equal to our tangential acceleration. Sure. So this you can just see that, right? The square root of 2 square root of 1 plus 7 is square. No big deal. Okay, so t equal to 0 case. T equal to 0, your magnitude of v cross a, well it's constant, just 4 square root of 2. The magnitude of velocity, that's just equal to square root of 2, and this is 0, so just 1 square root of 2, and then the magnitude of, so just dv by dt, so the tangential acceleration is like what? It's 0, so it's 0. Okay, that just means that kappa is just like 4 square root of 2 upon this thing cubed, so that's 2 square root of 2, which is 1, just 2, and then your normal, that's just this stuff upon square root of 2, just that, is equal to 4, t equal to pi by 4, that would just mean the moment of velocity would be something like square root of 2 and then square root of 1 plus 7s squared, just 7 by 2. So we made a common side, just like 2 plus 7, which is 9, so it's just 3. And the initial acceleration is like what? It's just, yeah, so this is this stuff, so it's 1 by 2, just so it's like 7. It's 7 by 3. Okay, what about the kappa? It's 4 square root of 2 upon 3 cubed. 27. 3 squared, 9. Okay, no big deal. Next question number 2. Oh, this isn't even so good. Wait, so this was, yeah, okay, whatever. So question 2 is r is this, and we wanted t equal to 0, so once again the velocity is just secant. If that's not going to be good, so it's sort of 3 secant, and yeah, that's what I'm gonna do. So we got square root of 3 secant square. The acceleration, do I really want to find that? I guess I'll have to. I don't really have another choice, fortunately. And square root of 3. This is not going good. I don't want to find this. I'll have a b plus a or some stuff. Sure, I'll just have to do it. So it's just secant tan square plus secant square, so just secant cube, and secant and tan common, just like tan square plus just tan, but oh, that's secant and tan, so that's secant tan square. This thing is secant cube, just secant cube actually. So you can take a secant common. It's like t square plus s square. I wish that would amount to something, but it doesn't. Okay, fine, no big deal. Here just have like 2 square root of 3 secant times secant tan, so it's just secant square and tan. Okay, right. So magnitude of velocity, that is square root of 3 secant square root of secant square plus tan. I don't know why plus tan, so that's just how it is. So since we want your tangential acceleration, we want to be doing it the correct way, so that's just going to be like, oh god, this isn't looking good. Not cosine, sorry, secant tan. The two cancels in any case. It's like secant and secant tan, so secant square tan, and then plus tan times of secant square, so secant square tan, just 2 secant square tan. Oof, okay. When will this nightmare be over? But I just gotta calculate this. At t equal to 0, so your tan is 0, your secant is 1. So this just turns out to be 0 comma square root of 3. This is, well, that's tan over there. This cancels, which is 1 over there, so square root of 3 comma 0. Your, right, that's the amount of velocity. So that just turns out to be like, I mean, this is square root of 3, no big deal. What about this? This stuff turns out to be, that's 0, that's 0, so it's just 0. That makes sense actually. Somehow it makes sense. That's very weird. Fine, it somehow just cancelled itself. Okay, never mind all that. So yeah, it cancelled itself, and you just have is equal to 0. So what does that mean? Tangential acceleration is 0. The normal acceleration is just v cross k stuff, so that's just like determinant, it's just that stuff. So yeah, it's just 3 upon negative of v, which we know is just square root of 3. Okay, just that, so square root of 3, just square root of 3 like that. Did I No, no, I didn't square it. Okay, and then kappa is just that thing upon and of the square, so just that upon 3. So just 1 plus square root of 3. Sure, that's okay. Move on. Question 3. Question 3 is the position of a particle in a plane at time t is find the particle's highest speed. Shouldn't be hard. Velocity is just a derivative of this stuff. Well, no, it's a unit vector. I know what this is. I don't like what this is. Oh wow. It's along. Yeah. Yeah. Ah, this is disgusting. It's not even along the theta thing. It's just t upon whatever. Fine. So find the particle's highest speed. Just gonna do it the normal way. Velocity is just what? So the numerator's derivative is just like 1 comma 0. So shit. 0 comma 1, sorry. 0 comma 1 upon square root of 1 plus t square plus this is 1 comma t upon 2 square root of 1 plus 1 not actually it's minus 1 by 2, so it's minus 2 square root of 1 plus t square to the power of 3, that stuff, that times of 2t, so this just cancels, so just t. Sure. I think I've seen this somewhere, I don't even remember where, but sure. Yeah, okay, so that is, so you'll just have a 1 plus t square multiplied on top. This is 0 in any case, so just minus of t, comma 1 plus t square minus t square is 1, and that upon 1 plus t square power of 3 by 2. Yes. Yeah, so we want the magnitude of the velocity, so this is like square root of 1 plus 2, which is gonna be like 1 upon 1 plus t square. Yes. So that's your, okay, particle's highest speed is when t is equal to 0, so it just becomes 1. So you got the speed, it's just this. Next. And that makes sense actually. This is when x is equal to 0, because your y is changing the most rapidly, right? Okay, question number 4. Oh sorry, that's when your y is, so that your x is changing most rapidly. Anyway, suppose r of t is equal to this, so that the angle between r and vector a never changes. What is the angle? I think I've seen this somewhere. Between r and a never changes. I don't know, I'm just gonna do the thing. So yeah, just gonna do, so like v is what? So it doesn't make sense by, but never mind. So just e power t, and then you got c minus s comma s plus c, and so your acceleration is just the derivative of that stuff, so it's e power t, and then you got c minus s, and then you got minus s plus c, so it's just 2c. Yes. Is that the thing? Minus s minus c, it cancels, it's minus 2s, sorry for that. Over here just got s plus c plus c minus s, so it's 2c over here. Cool. So your r dot a, or I should say r hat dot a hat, that would be something like cosine sine, that dotted with minus sine comma cosine, which happens to be 0. It's perpendicular somehow, which means it's perpendicular all the time. It's just pi by 2. The angle is pi by 2. Anyway, question 5. Fifth is, at point P, the velocity of an acceleration of a particle moving in the plane B is, okay, find the curvature of the particle's path at, it shouldn't be hard, curvature is just B plus A independent, so it shouldn't be hard. What is this? It's just 3 and 4, and that's like 5 crossed with 1 comma 3. I mean, you just take a derivative, so this just implies its magnitude would just be like 5, and then the determinant is like just 9 minus 4 is 5. So you just have 5 cross 5 upon, so you want the curvature, just velocity cubed, so it's 5 cubed It's only 1.5, easy as that, which is okay. It's 1.5. Next question. Next is curvature or radius of curvature? Just curvature. Question number 6 was for rho, it's just 1 by kappa. Find the point on the curve where the curvature is the greatest. So no big deal, the curvature is just this stuff. Not square root, it's supposed to be 3 by 2 power. So yeah, I mean this is just I don't know, it's e power x upon 1 plus e power 2x to the power of 3 by 2 whenever this thing is the highest. So when is the highest? That's a good question. So you want to have a 2 by 3 involved in this, just 1 upon e power 2 by 3, or I should say negative, yes, negative 2 by 3 x, yes, plus e power, so it's just 2 minus 2 by 3, which is 6 minus 2 is like 4 by 3, so it's just e power 4 by 3x. So we can use the usual what is this by 3 by 2. So we want to what, find where it's the maximum, is the greatest. So essentially just minimize this stuff. You can use the AM and GM inequality. So you can split this as half e power negative 2 by 3x plus half e power negative 2 by 3x plus, yeah, the usual, and then just use that stuff. So when does this happen? This happens when you have minus 2 by 3x is equal to 4 by 3x, which is at x equal to 0, right? Yeah, that looks correct. Yep, that is fine. So it's at x equal to 0 that we get the highest, which is just like 1 by 2 power 3 by 2. So it's 1 by 2 square root of 2. That's the highest curvature we'll get. Yes. Next question. Next question is, oh, so you want to find the point at x equal to 0. Sure. Which is like x equal to 0, y equal to 1. But next. And does that actually make sense? I think it does, because this is like e power x is something like that. So this is where the curvature is the highest. I don't know, but I'm gonna go ahead with that. Okay. Question number 7. Particle moves along the unit x circle in the xy plane. Its position from at a time t is this, where xy are differential functions. Find dy by dt if p dot I equal to the first component for velocity. So this is the x dot is equal to y. So if x dot equal to y, time t is okay. Unit circle in xy plane. So your these are just what it is. Sure. So motion clockwise. So you just have two equations. First is that x dot is equal to y. The second is that x square plus y square equal to 1. Right. So essentially what you're saying is that x dot is equal to square root of 1 minus x square. Right. So at any given x you have a good idea of what this is going to be. So just like dx upon square root of 1 minus x square is equal to t. So what do you really want though? Okay, is this motion clockwise or counterclockwise? Okay. It's just like what? It's equal to dt. Isn't that right? So x dot equal to y. Initially your y is just 0 and it may not necessarily be square root of 1. So it just depends. It depends on where you start. This could be clockwise or counterclockwise. It's actually not. Yeah, so okay. Think about it. So when it's in the upper circle at some point like this, its x component is like positive over here, sure. So yeah, just depending on x component you decide. Shit, what? No, the y component is positive, so its velocity's x component is positive as well. So it's moving in this direction. I know it's over here, it's negative, so its velocity is x component is negative, so it's moving in this direction. So what's happening is it's actually moving clockwise. Sure. Yeah, you could have actually plus minus over there because it does not actually guarantee anything. So it's clockwise. And that was just visualization. I mean, it didn't really feel like doing math. Question 8. Question 8 is you send a message through a something tube that follows the curve something. At the point 33, your v dot I is 4, so x component is 4 and your supplemental acceleration is minus 2. Find the value of v dot j and a dot, okay. So once again what you have is that vx is 4, vy, its acceleration around x is minus 2, and what we want to find is what is vy and ay. This shouldn't be hard because you know that y is just equal to 1 by 9x cubed, so y dot, or basically vy, that is going to be like vx times the Pascal's derivative is like 1 by 3x squared something, that times of vx squared. So this is at what? At point 3 comma 3, so your x value is 3. Sure. So your vy is just like 3 squared is like what? 3 times of vx, not squared, not squared, just vx. So vx is 2? No, vx is 4. So 4, so it's going to be 12. Sorry, vy, that's going to be 12. So the acceleration is like what? Your y double dot. That is, so 2x upon 3 vx squared plus x squared by 3 vx, so that just becomes ax. Yeah, I suppose. Yeah, it looks okay. So we wanted, we already have this thing, it's just 12. Oh, you don't actually require that. So your vx is what? 4. So this is 3. So you're like 2 times of 3 times of 4 squared upon 3 plus 3 times of, what is ax? Ax is minus 2. Okay. Cancels. So 60 times 2 is like 32. 32 minus 3 times of 4 is 6, which is like what? 22. 22 is the answer. Let's try comma 22. Sure. I'm just hoping what I'm doing is actually correct, just to be sure. This is 3. Okay, so vy is okay. Sure. This is fine. Okay, next. Next is question number 9. Let's go. Question 9 is characterizing circular motion. A particle moves in a plane so that its velocity and position vectors are always orthogonal. Show that the particle moves in a circle centered at the origin. Its velocity, position vectors are always orthogonal. Okay, so this is what you have, like r dot v is equal to 0. Sure. Moves in a circle centered at the origin. This shouldn't be hard. So come on. Okay, what is just r dot that's equal to 0, but guess what? That's like saying 2r dot equal to 0. But what is that? That's just equal to the derivative of r squared. Yes, or I should say r vector dotted with r vector, because that's just the way inner product works. And so that's equal to 0. What does that mean? This means like the norm of r squared, that's not changing, it's constant, which means it's in a unit circle, not a unit circle, it's just some circle centered at 0, 0. Stupid. Next question. Question 10. 10 is speed along the cycloid. A circular wheel with radius 1 feet and center 0 along the right To the right along the x-axis at half turn per second, see the accompanying figure. What figure? Okay. Circular wheel with radius 1 feet. Center C rolls to the right along the x-axis at a half turn per second. Half turn per second. Full turn per 2 seconds. Yeah, the frequency again, never mind. So basically, the x velocity you have given us for the center. Yeah, because half a turn just means you have half a circumference covered by that point. Sure, center has covered half a circumference, so it's like what? It's just, what is the radius of this? It's, oh, you actually gave us gave us the r vector directly, but yeah, just to be sure, your x direction is just like pi t, because in 1 you have pi if radius is 1, given the radius is 1, and so that's the center, and your point P at 0, so at t equal to 0 it was at what, it was at 0 comma 0, right? So yeah, with respect to c, since this is moving at angular velocity of what, something like that, so just pi t basically, right? Yeah, yeah, so the angle was initially just minus pi by 2, and the angle is decreasing by pi t, so it's minus pi by 2 minus pi t, so just the vector will be consist of that, minus pi by 2 minus pi t. Sure, so cosine of minus pi by 2 minus pi t, that's going to be like pi by 2 plus pi t, which is just minus sine of pi t. The sine of that is just minus cosine of pi by 2 plus pi t, or minus sine of pi by 2 plus pi t, which is positive, so it's minus cosine of pi t directly. So yes, this is correct. Sketch the curve traced by P during, come on, I don't want to. Basically till 3 pi, right? Oof, this is not going good. So yeah, at t equal to 2 pi you will hit the bottom again and all that. But fine, just sketch the thing. So this is at 2 pi, this thing at 0. Yeah, that seems about right. So it would have covered this distance. It's kind of a weird thing. In 1 second you have pi covered. Okay, so at, yeah, but it doesn't matter what angular velocity. So whatever omega you had, right, you would just be having omega t covered. Yes, so it would always be something like this. It would be omega t minus sine omega t, and then comma 1 minus cosine omega t. That's just how it's going to be all the time. So it shouldn't matter, it's just omega equal to pi in this case, and in any case you will get the same thing. So this is x equal to 2 pi, but at t equal to 2. If this was 2 pi, angular frequency equal to t equal to 1. Just keep moving, so it's a cycloid, the usual stuff, blah blah blah. Next. Okay, question number 11. So 11 is, oh, it's not, okay, so A was the thing. Sketch. Find velocity and acceleration at t equal to 0, 1, 2, 3, and add these vectors to, so at some certain t value basically. So velocity vector already given us the r thing. You could do it directly, just the x component plus the angular thing, so just get the thing, but whatever. So since you have the r vector, just do it like this. It's like what? It's just what, omega comma minus omega cosine just get rid of that stuff. Okay. Okay, cool. Yeah, this makes sense, I think. So you got your velocity acceleration, you want it equal to 0 and all that. So omega equal to pi. So v0 would just be, alright, then now it should be v a t equal to 0, 1, 2. So we'd have velocity would just be, so at t equal to 0, its cosine is just minus 1, so it's 2 comma 0, right? So it's just omega times of 2 comma 0, which is like 2 pi comma 0. The acceleration is minus pi square over here. Okay, what about at t equal to 1? Oh, sorry, this is at t equal to 1. At t equal to 0, it's completely different. It's at t equal to 0, it's just, this thing is 1, this thing is 0, so just 0, 0. And then acceleration is still kind of weird, isn't it? The velocity is 0, 0. That makes sense because it's going back at the same time front, so yeah. Then the acceleration is like 0, 1 over there, just omega square, like pi square, so just 0, 1 pi square. Okay, never mind. And at 2, it's, so it's 2 pi, so it's 1, so it's the same thing as 0, 0. For all it is in fact circular. Okay, and its period is in fact just 2, so no big deal. Okay, next thing. Next we have question C. C is, at any given time, what is the forward speed of the topmost point of the wheel of C? Is the forward speed? Oh, come on, it's just the 2 times of Vx stuff, because we know that the point of contact doesn't have any speed. This has some speed. Let's try. This is done so many times. But yeah, so what's the Vx velocity thing? It's just pi. So this is going to be pi, it's 2 pi basically. I don't want the speed, we don't want the velocity. Okay, whatever. Next question. That is 11. Projectile motion. A shot leaves the thrower hand 6 feet. Oh no, it's that stuff. 45 degree, 44 feet per second. What is it? 3 seconds later. At a 45 degree angle at 44 feet per second. So your u is given to you, angle is given, leaves the hand, this thing. It's just the usual stuff. So come on, not gonna be a big deal. So it's just 6.5 plus ut plus half 80 square. So u is like 45 degrees is 44 by square root 2. That's like 22 square root 2. So 22 square root 2 t. This is the y coordinate. Sorry, the x coordinate is just like 22 square root of t times of. So t is just 3 seconds. So just 3. And I'm hoping this is like feet per second. This is bad. So 3 feet. So what is g in feet per second? I think it was 32, right? Yes, if I'm not mistaken. So g in feet per second square, it's 32. Pretty much. Okay, so this is 22 times 3 square feet, and then you want 6.5 plus ut, which is the same thing. It's 22 square root of 2 times of 3 plus half it equals minus g is 32 by 2 is 16. 16 times t square, so just 16 times of 9. That's the thing. So that's gonna be like what? 66 square root of 2 comma 6.5 minus 16 times of 9. That is some messed up stuff. It is just that, isn't it? 32 feet, 54 feet per second above the ground. I feel that this isn't going to work out. I don't know. So it's just 66 square root of 2 minus, let's see, what is 6 times of just like 9, and then 36 is like 126. So 126 minus 6.5, that's like 1. Oh, what am I doing? 126, right? Oh god, this is 6.5, so it's just like 119.5, sure, so just minus 119.5. Okay. Cool. So this is done. 11, right? Yeah. That's the point. Sure. Next, question number 12. 12 is a javelin leaves the thrower's hand 7 feet above the ground. How high does it go? 10 feet above the ground at 45 degrees. So highest point is like at half the usual stuff. So how do you find the height basically? So the full time to go back to the same x value was like 2 uy upon g. So that's our t. And so it's just half gt square because at that point the velocity is 0. So it's just half g times this stuff squared. So it's just like 4 got stuff. So it's just 2uy squared upon g. That's the thing. That's your height. So for this height, what's your uy? 45 degree. Sure. So this is 40 square root of 2. So just 2 times of 40 square root of 2 square. It's like 1600 times 2 upon g is 32. Sure. So it just becomes like this is 1 2 expands. So it's just 200. So it's 200 feet. That's how high it goes. Plus this stuff, this 7 feet. So 207 feet. A very bad estimate, but assuming that g equal to 32, this actually kind of works out well. Anyway, it's gonna be smaller than that, yes, but approximately 200 feet. Like, yeah, this is much more. This is like much more actually, right? Yeah. Yes, I suppose that's correct. 1600 times 2. That's other 2 on. Yeah, it's okay. It's okay. How high does it go? It's just that high. Okay. A golf ball is hit with an initial speed, something horizontal, from a point rising a foot. So ball v naught alpha from a point that lies at the foot of a straight sided hill that is inclined at an angle of phi. Why do I feel I've seen all of this somewhere? Because I probably have. Where this show that the ball lands at some distance, so just boom, whatever. Measure it up to the face of the hill and show that the greatest range that can be achieved. Where did it put the other stuff? When what? Putting this there, right? Okay, when alpha equal to, okay, cool. That is, it's when bisecting it, which makes sense because like for phi equal to 0, 45 degrees. So here it's also bisecting it. Makes sense. Yes. So alpha is like varying. Hey, what? Initial velocity bisects the angle between the vertical and the hill. Oh yeah, so it's something like this. Okay, no big deal. So you just want to find the maximum range. Think. You have some something in that direction, sure. We'll have to break it. You'll have to break it like that. So we'll just have to do the g tangential g normal thing. Right. So given some g tangential and g normal, this is a retarding potential, this is also a retarding potential. So you have vx, vy. So we'll just put it as vt and v normal. So the time of flight would just be like 2 v normal upon this stuff. I mean, what's gonna happen at the burst? This is like going down, like, yeah, if your g tangential is like very much, although we know it will never be very much, it doesn't make sense for it to be going backwards. That doesn't make any sense. But yeah, so what could happen is it could go something like this, and then so rotated, like from this perspective it would look like it's going back, which is bizarre, but that's just how it is. So t is v 2vn upon g, right? And then the range by that point is just 2, so ut plus half at squared, right? So it's just going to be, so this minus g normal, sure, ut. So where did it go? What's the u? Okay, so it's just vt times this, so 2vn vt upon gn, okay, minus half g t half g, okay, t squared, so just this stuff squared, just like 4vn squared upon gn squared, okay, it's bizarre, but this is the value, so okay, you have to put it in angles now, so it's 2v squared, so normal component is making this angle, sure. Okay, so with the inclined, what angle does it make? Alpha. So your V naught is just at cosine alpha. This is sine alpha. So it's sine alpha cosine alpha. Wait, alpha is with. Oh, alpha is with that. So it should be alpha minus pi by 4. So let's call that thing as beta. So beta cosine beta upon Gn. Gn is. So it's making this 90-degree angle. And that's what 90-degree minus pi, I suppose. So that's phi over there, sure. So it's just cosine, yeah, cosine phi minus 2. So you just got like some g over there, sure. Something upon g. This would just be cosine square, and then that's sine square over there. So that's sine phi cosine square phi. And then Vn, so Vn was the sine thing component, so the sine beta square. Yes, yeah, this actually makes sense, huh? This is our quantity. You have to factorize as far as v square, which is 2v square upon g times, so sine beta cosine beta upon cosine phi minus sine phi upon cosine square phi, and sine beta square. This looks awfully familiar to something. So this thing is like what? So we just take sine beta upon cosine phi common, or cosine phi square in fact, and this becomes cosine beta cosine phi minus sine phi and then sine beta. That's just cosine of phi plus beta. Yes. So phi is constant, we can't really change that, but this we can probably change. Yeah. You should probably just put a derivative equal to 0 or something like that. Yes. So what should happen is something like cosine beta and then cosine phi plus beta, and then we got minus sine beta sine of phi plus beta. That thing that has to be equal to 0 pretty much. Or you could just split this apart by doing like half of all that stuff, so it's just like the usual stuff. But anyway, the point is that cosine of phi plus 2 beta, that has to be equal to 0. So beta has to be, wait, phi plus 2 beta or what? Wait, what? Something is messed up with all of this. Minus, isn't it, right? Something doesn't make sense over there. You did a plus, yes. That's just how it's supposed to be, right? Was that a sign? What was it supposed to be? To the cosine phi off, right? Yeah. What the hell? Sine beta out. Why would you have beta equal to minus? That doesn't make sense. Oh, it doesn't make sense obviously. So what should happen is that cosine of phi plus 2 beta, that has to be equal to 0, which means what we do is just we set it to pi by 2. So phi plus 2 beta is pi by 2, so 2 beta is just pi by 2 minus pi minus phi, half of that, so it's just pi by 4 minus pi by 2, which is as expected. Yes, and then that plus phi by 2, that's, so that plus phi, that would be alpha, so we got the thing. So yeah, it's a nice result, I suppose. I definitely don't want to be doing all of this calculation like in an exam, because it takes time, but fine, we did it. So it's question what? This thing is Question 13. Oh, you even have the range. So the range yeah, that makes sense. So it's just, that's exactly what we got. So just 2v naught square cosine alpha, and then sine alpha minus beta. So sorry, alpha minus phi. So just like, we just call it beta, I suppose, upon g cosine square phi. So once again, just to remind you, this thing is phi, this thing is beta, and then this whole thing is alpha. So if phi was 0, this would just be beta is equal to alpha. So this just becomes 2v naught square sine square beta by g. This is a more general formula, it seems. Right, this is kind of nice. I should remember this. Should have remembered this. Now there's no point, but whatever. So this is the range for an inclined surface. Okay. Fine. Next, question 14. Question 14 is javelin. Okay. So something East Germany set up a men's record by throwing a javelin something feet, inch, whatever. Assuming that this guy launched the javelin at 40-degree angle to the horizontal above the ground, what was the javelin's initial speed? 40-degree angle. So they given us theta. Theta is 40 degree. The horizontal. Okay, so the y naught thing is given. It's just 6.5 feet. What was the javelin's initial speed? So v naught we have to figure out. Call it u. That's the usual thing, right? So that what? So the height is reached 262 feet and 5 inch. Okay. What's the inch? How many inch is 1 feet? 12. So this is like 5 by 12. Okay. What is that? It's something like 0.5, pretty much, approximately. So what you're seeing is it's 256 feet of height from the starting point. Okay, so 256 upon, so h is 256. That's just equal to 2u square upon g. Easy. G is just 32. So it's just be like u square upon, so sine square theta obviously, upon g. So g by 2, or that's 16. So 256 times 16, that's equal to u square sine square theta. I can just take the square root of that. So it's just like 16 times of 4. That's equal to u sine theta. So the u is just 64 upon sine whatever this is, 40 degree. 64 upon sine 40 degree. Sure. Alright, next question. Question 5. Okay, question 15, sorry. 15th is, okay, so getting back to these normal things. Unintended. Find the length of the curve in something whatever. It's s basically. It's just integration of the velocity magnitude. So it's like what, 2 cosine, 2 sine, just 2t. So it's like square root of 4 plus 4t square. Yes. Yes. So it's just 4 square root of 1 plus t square dt from 0 to pi by 4. What is this quantity going to be? Pretty much. So you just set t equal to tan theta. It's just like 4 integration. This is actually really bizarre. This shouldn't be the, yeah, but that's just how it is. Fine, no big deal. You can do it. I've done this sort of stuff a lot of times. So it's just what, put that as tan theta. So it just becomes like, that's just secant. So just secant theta. So this is from t equal to 0 to pi by, this is, that's weird. Pi by 4. Why would you put, what? That doesn't make sense. Pi by 4. You would have to have a lot of problems with it. Fine, so 0 to tan inverse of pi by 4. This is some new value I have never seen. Anyway, this is secant, and then d tan is just secant cube, and then dt. That's your thing. And this is, I think, doable. Yeah, this was doable if I remember correctly. So integration of secant cube, I think I kind of remember it. So it's like secant square, you integrate, and then secant you differentiate. So we call this thing as I as integration of secant cube theta d theta. That would just be like integrate secant cube, just get tan theta, that times of secant theta. Okay, and then minus, so you integrate it as tan, and then differentiate it, so just like secant and tan square, secant theta tan square theta, and tan square theta is just secant cube minus 1, so it's just secant cube minus 1 over there, d theta, right? So it's just what? This is equal to tan theta secant theta minus is plus, so it is plus, integrate it just like theta, okay, minus I. So is that correct? Firstly, is that correct? Did I do it correctly or not? Tan theta secant theta, that is okay. Differentiated, that's just like secant tan square, then tan square to secant square minus 1, sure. Oh, it should be secant theta over there. I knew it. I'm doing something stupid. It always happens. Yes, that's how it should be. So now secant theta, that guy's integral we know is just natural log of secant theta plus tan theta. This is like classic Pranav. Yeah, but natural log of secant theta plus tan theta. Why do we do these stupid things? Like I mean, I can do quantum mechanics, but then I mess up like normal linear algebra. This is anyway. So minus I. Yes. Okay, this is cool. So it's just half of that. So half. So we want to evaluate the limit actually. This is from theta equal to 0 to pi by 4. So at 0 it's messed up. Oh wow. Would you look at that, huh? At 0 it's really messed up, isn't it? Means just no, it's not, because it's okay, that thing is okay, and this is also okay, so it's not messed up. So it's just tan inverse of pi by 4. That's what theta would be. So tan theta is just pi by 4. Secant is like square root of 1 plus pi by 4 squared. So it's just that pi by 4 square root of 1 plus pi squared by 16. That's the first part, and then plus natural log. So the 0 part just gives us 1, so it doesn't really matter. So this natural log of square root of 1 plus pi squared by 16 and plus tan. So it's just plus pi by 4. It's supposed to be an absolute value, but who cares? And it's supposed to be half of all of this combined. Yes. Next, I suppose. That's just the arc length value. It's not the equation, but oh, it's actually supposed to be 4 times of that. So what should happen is 2 times of all of that. So it's 2 times of this. So it's just like pi by 2 square root of 1 plus pi squared by 16, and then plus. So it's 2 times of that, just like square that, or don't square that actually. Pi by 4 plus square root of 1 plus pi squared by 16. I really hope this is correct. It will be, most likely. I've done this sort of stuff for quite a while. If you know, you know. Question 16. Question 16 is this stuff, the usual. So t power 3 by 2 is just like t power 1 by 2 comes at the front. So velocity would be something like minus 3 sine, comma 3 cosine, comma, what's on the front is 3 t squared. This is bad. This is like, okay, it's just gonna be 3 minus sine cosine t square. I don't want to be doing this stuff, but I'll have to. So your s is just integration from 0 to 3. Well, this 3 just comes out. Square root of 1 plus t power 4 dt. Yeah, now this is bad. T power 4. I don't even remember how do we do this. T square is okay, it's doable. T power 4. Do I just leave it like that? No, there must be some way. I think. Maybe some sort of. Oh, okay. I see. This is weird, but let's try it out. No, this won't work. This just won't work. Even if I do that, so t squared take out, and then this is. But you have to try it. You have to try it. You can just give up like that. So s is before, huh? Have I seen this before? No, I have not. Yeah, just do it. Just do it, the usual stuff. So just, you have done this thousands of times. Nothing big. It's just t square root of t square plus 1 by t square, and then dt. And what I'm thinking for is something like t plus 1 by t and then t minus 1 by t. I can break it into these two. So this would be, yeah, and then you can just square that stuff. Sure. The derivative of that is just, does it make sense? What about a t cube factorization out? You can't do that, that's stupid. How about t power 4 factorization? You just get t squared, so no, it doesn't work. This, maybe. Okay, so what's the derivative of something like t plus 1 by t? Sorry for that, that's not important. Okay. Suppose, so first we have to factorize that with just t plus 1 by t and then t minus 1 by t. You can use that directly, that's one thing, sure. So if you can break it, you will be done, but that doesn't work quite well, because you don't have those factors. If you don't have those factors, you can't really do anything. How do you take the derivative of that? It's like 1 minus 1 upon t square, so you need to have a 1 upon t square somehow. Yes, but how? That's a good question. You can do a squaring, sure. So it's something like, that won't work. That won't work. That's just not gonna work. We know. What about the inside stuff? Oh, I see. But hey, that doesn't. No, that doesn't work. You have to have it squared. Otherwise, you can't do it directly. I don't think this has a nice answer in any sense. Differentiation integration stuff. What if I just differentiate that and then integrate the 1 alongside? It's just like you get t upon 2, all that stuff. Okay, it doesn't make sense. Well, we can do it numerically, that's one thing, but this must be integrable, right? Otherwise, why would you give me that? I must have done some sort of, oh shit, I definitely did some sort of a mistake. This isn't the thing. Yep, stupid as a. So it's 3 integration square root, yeah, the velocity vector I got was wrong. So it's what? It's 1 plus, so it's half over there. That's the square just plus t. This was even easier than 4. So it's just what? It's just like 3, and then it's v1 plus t over there. So it's just e power 1 by 2. Integrate that, is 3 by 2 upon 3 by 2. So just like cancel, so just 2. Sure. And this is going from 0 to 3. So yeah, it's just at 0 it's just 1. And this is, so it's 2 times, so at 3 it's 4, square root of that is 2, power 3 is 8, 8 minus 1 is 7, it's 14. Okay, so that's the arc length. That was actually much easier. Okay, question 17. Question number 17 is exercise 17 to 20, find t and b and kappa and tau at the given value of t. Okay, the usual stuff. So r is given, we want to figure out what all of these values. T, I don't like, okay, but you have to. That's just how it is. So let's go. Velocity. 3 by 2 comes on the front, it's just 2/3. Okay, 2 by 3, it's negative. In fact, so everything can just be figured out from t, so you can just completely like forget the value of v. Let's see if that actually helps. So t would be, so cancel all that 2 by 3 stuff, or the 1 by 3 stuff, it's more like it, and just squaring that. So we just have something like 4 times of 1 plus t plus 4 times of 1 minus t, and then plus 1. So that would just be 4 plus 4 plus 1, which is 9. So sort of that is 3. So this whole thing magnitude would just be 3. So this is actually already a unit vector. Oh, I should have known. So this is okay. So the t dot thing is just the same thing as v dot. It's just acceleration, which just take a derivative of this stuff. So it's like what? It's 1/3 1 plus t power negative 1 by 2, comma plus 1/3 again, I suppose. And then that's just 0. Okay. So you got a t dot, your normal vector would just be like normalizing that stuff. So it's only 1 by 2 basically. So just 1 by 2. Hey, no, that's oh shit. That's not good. Yeah. But hey, it's in the same direction, right? So you can normalize it later. But do you want to find n or not? You do. You unfortunately do want to find that. Damn these. So it's just 1 upon square root of, well, take that thing. Okay. It's 2 upon 1 minus t square. That's the factor you will multiply with. This will just be like 1 by square root of 2, and then this goes inside. It just becomes, it cancels one of the square roots. So it's just square root of 1 minus t, and then square root of 1 plus t. Okay, amazing. It's a normal vector, which makes sense, I suppose. This is just supposed to be normal, so yeah. Yes, okay, next is, we also have a 0. Okay. Next, what you want is the b vector. So b is just t cross n, so it's just this cross that. Yeah, you have to do it. So it's just 2/3. Not even 2/3, you just have to have 1/3. This crossed with which is this is 40. Did I do that correctly or not? I think I did. And that's okay. Sure. Okay. So this is like what? Okay, this is your b. This is a shouldn't there be negative somewhere over there? It should be negative, right? Yeah, it should be negative. Oh, I see. This is also bad. It should have been a negative. So this would just be 2 times of 1 plus t plus 2 times of 1 minus t. This is 4. Makes sense. So it's something like 16 plus 1 plus 1, which is 18. Square root of that, which is the square root of 2. So this is okay. It's a unit vector. Next, what we want to do is find what? Let's just take the derivative directly. So dv by dt, because we want to find the kappa thing, right? Yeah. So dv by dt is just like the bit of this stuff. So it's just 4 by 3 square root of 2. So So this should be along the n vector, I suppose. Yeah, yeah, okay, I get it. So this is like 4 upon 3 square root of 2. So since we want, yeah, we have to take that outside. So just that 2 comes over here, just 2. And then just square root of 1 plus t comma 1 minus t. So just minus t square basically. And then you just have this stuff square root of 1 plus t. So 1 minus t, sorry. Square root of 1 plus t. Which is n, right? Okay, with the square root of 2. So our kappa is just 2 upon 3 square root of 1 minus t square. Okay, cool. So you got all of that. Not kappa, it's called tau, sorry. You want to find kappa or not? Yeah, you do. This never stops, does it? So it's just t dot upon so it's dt upon ds, yes, which is just t dot upon the velocity. That's what kappa is, right? I mean, that is the thing. That's just how it is. I guess that's just how we define kappa, right? It's like v cross a. Yeah, the e square stuff. Cool. So we already have the t dot thing. We normalized it to get the n vector. But anyway, what was the magnitude? The magnitude was just 1/3 square root of 2 upon 1 minus t square. Okay, and that thing upon magnitude of velocity. So the velocity is this. It's a unit vector, so it's just that. That's what kappa is. It was much longer than what I thought it will be. Okay. Next, question number 18. Okay, once again the same stuff, T, B, and all that. So oh, you actually had a value. Wow, I did all of that for nothing. Anyway, just good practice, I suppose. So yeah, just find the velocity and then completely forget about it. Okay, this time I actually find the proper velocity. Do I need the acceleration? I do need that. It's not like I can't figure out everything with just acceleration. And yeah, can I figure out the normal vector with just acceleration? Not really. I need t dot to be able to do that. Or do I actually don't, because I know that B is along V cross A, but yeah, oh, okay, we know what B upon dt is along minus n. That doesn't make anything like happen. Where would the n vector be pointing? It would be pointing to not V cross A. It will be pointing to V cross A cross something. This is stupid. I don't want to be doing that. It's probably just better if I find t directly. So what is V? V is just e power t. Nice. You know, this isn't quite helping. Probably it's better to be using complex numbers so that I can get some stuff done directly. Interesting. Think about it. Yeah, I could just say iota 2t and it wouldn't be a problem. You can find v vector as well, and making a cross product between these two wouldn't be so bad, since all just like rotations and stuff. So e plus a you can figure out directly. What about the acceleration? That too you can just figure out directly. And like taking cross products isn't a big deal at that point. I think that's a good idea. So I'll just rewrite this whole thing in terms of complex numbers. So it will just like e power t plus iota 2t, so 2 iota t. Right, or I could just say 1 plus 2 iota times t. And that with e power 2t, so e power t. Yeah, that's the velocity vector. Or acceleration, which is be like 1 plus 2 iota, then e power 1 plus 2 iota t, comma e power t. The usual stuff, And then, so it's not a Ramos, it's actually the art. It's like 1 plus 2 iota squared. The usual, come on, it's not a big deal. In fact, you can probably just have like a general formula for this, right? And then what we want to find is our t vector, so you can figure out the magnitude of the velocity easily. So this is going to be like square root, so the e power t comes out, and then it's just square root of 1 plus 2 iota square, so it's just that norm. So just 1 plus 4 plus like 1, right, which is 6. Then yeah, this is okay. V cross A you can kind of figure out. I wonder if I can actually do it as complex. I don't know. This seems really bad. I can probably split it, So the e power t comes out, so it's just e power 2t, and then you just have this. So in the xy plane, what you have is like 1 plus 2 iota. This is some stupid stuff. Yeah, e power 2 iota t. So e power, that t just went out, right? Okay, just 1. V cross A is just 1 plus 2 iota square e power 2 iota t. 1 as well. Okay, now think about it. What is it actually doing? E power 2t 2 iota t is some vector, and then you have this, and then yeah, this is like whatever 1 plus 2 iota does, and over there it's just like 1 plus 2 iota applied again, so it's some vector in that direction. Sure. Now see. Oh, this is interesting. Hey, so you can split stuff, right? Yes. Think about it. So you know that k hat cross any complex vector, it just rotates it by e power I pi by 2, right? Okay. Yeah, and then you also know that k hat cross k hat would just be 0, so that doesn't really matter. And you also know that, I see. So you can split stuff. That's an important thing, I think. Okay, let's try to do that. Let's see if this actually works out. So e power 2, this is the first time actually trying it out, so bear with me. So first I'll just do the k hat stuff. So what that will do is just apply a pi by 2 rotation, so just iota times 1 plus 2 iota square e power 2 iota t something, and then 1 this vector plus, okay, so this actually going to be 0 because it's a rotation, so sure, and then plus this, so there's no k hat component, okay, and it's on xy. With the, okay, it's gonna be negative. It's negative, right? It's like it's doing an inverse thing basically. Okay, so it will be something like plus negative iota 1 plus 2 iota e power 2 iota t. So just adding like that directly, and 0, and yes, so the cross product of these two vectors, which you know because you know the angle between these two. So it's just this one is rotated by 1 plus 2 iota over there. Sure. So if this was like framed as the x-axis vector, then this would just be like 1 plus 1 comma 2. So whatever this determinant is, which is 2 obviously, yeah, when you rotate both vectors, it doesn't change the determinant. So sure. Wow. Okay, I actually did something nice. This is a nice new way to think about it. Yeah. So it's just plus something in the k component, that something is just 2, happens to be 2. Coincidence, and 0 comma 2, like that. Huh. That's amazing. Okay, so this is like what? It's just e power 2t, and then you have something 2, and then e power 2 iota t time, and then you get 1 plus 2 iota. And so what you have is just iota times 1 plus 2 iota minus 1. So it's like iota minus 2 minus 1. Yes, which is iota minus 3. So that's V cross A. You probably have to be doing the usual stuff, just multiply this out. So it's what, minus 3 minus 2 plus iota minus 6 iota, which is minus 5 iota. So it's minus 6 minus 5 iota. Even if my answer is wrong, the fact is I discovered a new way to be multiplying complex numbers, these kind of vectors, so I can probably use that. I have to see if this actually makes sense, but yeah, I probably can use this. So this is the new vector. Now this might be incomprehensible to you, but I can use its properties very nicely. So it's just like when you have V cross A, you can get that directly, which is e power 2t, and then this gets magnitude just like 4 plus, well, this doesn't really matter, so it's just like 36 plus 25, which is 40 plus that is like 65, so it's e power 2 t squared of 65, something like that. I'm just not very sure if this is correct thing or not. Yeah, let's see. I don't know what's going on over there. But anyways, just have, yeah, 1 plus 2 iota, the usual stuff. Oh wait, actually it's sine and interesting. So there's probably a phase difference that you have to account for. How do you just do that? How do you just I hate this. It's pi by 2 minus t that you'll have to put it inside. So it's like 2i times pi by 2 minus, so it's just negative n. Oh, so this actually was a wrong calculation because this is different, this stuff, from cosine t comma sine 2t, but apart from that, this is actually a nice method. I just need to formalize this. I need to be sure what I'm doing is actually making sense, otherwise it's all good. Yeah, so our current problem is something like this, that you're given two complex numbers, right? So given something like r1 e power I theta 1 and some z1, and then that crossed with r2 e power I theta 2 z2. How do you cross multiply these things? Well, so first what you will do is just break it into a bunch of components and then try to do this stuff. So okay, think. So it will be like, first we just do like z1 cross this, so it just rotates by iota, so it just becomes iota z1 yes, and then 0, okay, plus, so you have to do that stuff, okay, so you multiply by z2 and you just get 1 negative iota, so negative iota z2 r1 e power I theta 1 0, okay, and then plus, so you multiply these two together, right, and cross multiplying that, so compared to theta 1, this is going like that, okay, this is cosine and sine, right, so it's theta 2 minus theta 1, sine of theta 2 minus theta 1 is what we'll go for. Yeah, sorry for that, that's some weird stuff. So it's actually like this, it's r1 in this direction, it's r2 cosine and r2 sine, so it's r1 r2 and sine of theta 2 minus theta 1, that's this quantity. Yes, completely in the k hat. Yeah. So what this turns out to be is yeah, this is weird actually. That is like this. You would probably be able to do it just like that, but so you should be having something like a determinant thing. Thinking. How would you write it? What I would do is I would write it as r2 e power I theta 1, the times of r1 e power I theta, sorry, the 2 the 1 conjugate, right, the imaginary part of that. Yes, that's actually how it should be. I see. So in that case, it would actually work out really nice. Cool, it would. It really would work out. So the R1, R2 you have to factor in. You can't just be doing it directly. Okay. And apart from that, you have these guys. So, something like IZ1 R2 e power I theta 2 minus I Z2 R1 e power I theta 1. So this is just the determinant. Like, look at that. It's iota over there and it's iota over there. Except you just have to add an iota. So it's just the iota determinant thing. Yeah, so it's just this complex determinant. And you have this. Interesting. So I could really be just using this stuff a lot. Hey, so let's actually give it a try. So try multiplying some very normal. Let's just say I do this stuff like this. So 1 crossed with, right? So we know that this would give me something like minus 1. No, okay, that's really 0. Sure, yeah, minus 1. This is 1 and 1. That should be the answer. But what we can do is rewrite this as 1 1 crossed with iota 1. Sorry, iota minus 1. So the first component would just be like minus 1 minus iota, and the second component would just be like, you take these two guys, there's no z involvement, okay, you take the complement of this guy, so it's minus iota, you multiply these two, so it's just minus iota, and the imaginary part of that, so it's just minus iota. Oh, okay, remember that it's just minus 1. So that is equivalent to saying minus 1 minus 1 minus 1. That's weird. Why did that happen? Oh, because you have to multiply this by iota. Sorry for that. So this has to be like this times of iota. And over here you have to take the conjugate of the first part, not the second part. So it's actually just 1 which you take the complement with. Right? Yeah. That's just 1. And then you just multiply and then take the imaginary part. It's minus 1 somehow. It should be 1 though. Why did I write a minus iota? This doesn't make sense. Okay, so this should be iota pretty much. Just iota over here. So the imaginary part of iota, which is just 1. Over here it will be like iota and then minus 1 minus iota. Yeah, sure. So it's just going to be like minus iota plus 1 1, which is it, what am I doing? Is this all correct or what? Is 1 minus 1 and 1? Okay, what the, seriously, what is going on? So it's z1, Oh, there's a minus factor in there. Sorry for that. So this should be minus iota times this. So it's just iota and then minus 1. Okay, so this is plus 1, this is minus 1. This is the full formula. Yes. Oof, that is interesting. So if x1 is a complex number, z1 is just some z coordinate, x2 is another complex number, z2 is another so the cross product would pretty much just be like this. It would just be minus iota, this determinant, x1 z1, x2 z2, and then over here would just be the imaginary part of x1 conjugate x2. Yes. Now we are finally getting to the thing that you want. Okay, amazing. So you could just use this all the time, I suppose. Yeah, this actually makes sense. I should have thought about this a lot earlier, because all of these are of the same sort again and again. Anyway, I don't have the energy to be doing this again, so I'll just do it till 20, just see if this new formula that I figured out actually works. And then, like, I don't know, let's see what happens. Okay, so for 18th we'll rewrite this whole thing as, so your r vector is, so sine 2t and cosine 2t, which is pi by 2 minus t, so it's basically like pi and all that. It's iota pi, which is minus 1, so it's just minus e power t e power minus iota. So it's just 1 minus iota times 2. Yes. Okay. Then you just have e power t. So your velocity vector is just derivative of that stuff. So it's negative 1 minus 2 iota e power minus 2 iota. The whole reason is because this just makes everything so much simpler. You don't have to worry about all the integration, differentiation and all that bullshit. So yeah. Okay, now we are finally to the point where we need to figure out stuff. So just magnitude of velocity is just going to be, so you take the e power t out, and then this just becomes square root of 1 plus 4 plus 1, which is square root of 6 as usual. Your v cross a, that's a nice quantity. So what is that going to be? So once again, remember the formula, you just have minus iota times this determinant. So you can just take the e power t stuff out, and so this just becomes like e power 2t first, and then this just becomes this, so it's just minus 1 minus 2 iota e power minus 2 iota t. I suppose what I'm doing is correct. Yeah, I guess so. Yeah, it's okay, it's not a big deal. Right, I'm just pushing it forward, it's not a big deal at all. Okay, and then so just be 1, and this crossed with right. So now this is much more simpler with the formula. So for the z coordinate, you will just like take the conjugate of this, multiply by that, and there you go, that's the value. So it's just this negative, just whatever. And so 1 minus 2 iota non, that is 1 plus 4, so sure, it's just 5 times of 1 minus 2 iota, the imaginary part of that. Yes. Am I doing it correctly? I am, obviously. So this is minus 10. Okay, just conjugate it and get that. This is okay, this is not a big deal at all. On the top we'll just have this determinant, so you just have this e power negative 2t stuff outside, 2 iota t, sorry, and then you will just have this and that, so it's just 1 minus, so negative, you can also take outside, it just becomes 1 minus 2 iota minus 1 minus 2 iota square. So it's just 1 minus 2 iota I can take outside, and then just 1 minus of that with this, so just 1 minus 1 plus 2 iota, which is 2 iota. But remember kids, you have to multiply by minus iota, like that was an important thing, right? There you go. So iota and minus iota just cancel, they are inverses, so it's just this, so it's this quantity. The whole reason to be doing it like this and not the other way around, like with normal differentiation, integration and all that, is because now I can do this. All I have to say is the magnitude of p plus a, that's going to be e power 2t, and then this stuff. So I can just take the 2 outside, and then just becomes 5 squared is like 25, square root of that value. So of 5 squared plus, so this thing norm squared, that is 1 plus 4. That's like 29 plus 1, 30. So sort of 30 over there. Cool, isn't it? Yep. So that's how it is. So what do you have? You just have the kappa thing as that's what we want to find. It's just the magnitude of v cross a. So actually this directly uses of a t thing, and the normal vector we kind of have to figure out. You still have to figure out normal vector, huh? I don't want to. I just don't want to. What are you gonna do? Huh? God. You probably also should be like taking a dot product with something else. It's taxing, isn't it? So you probably have to figure out the a dot and then take a dot product with that. It's gonna be like e power 3t, and yeah, so the 1 minus 2 iota e power negative 2t part is like the same. You can just make one of the e power t come inside. Actually that we can remove directly, so it's not a big deal. It's a square over there, and it's gonna be a cube, so the square remains, right? The norm of that is like 5, so it's just minus 2 times of 5 and 5 squared, so it's like minus 2 times of 25, and then you got the dot product of 1 comma 0 with 1 comma minus 2. Yes, no, actually 1 minus 2 iota squared, right? So that would be like 1 minus 4 is minus 3, so minus 3 and minus 4, which would just be minus 3. Yes. Wow, that's a lot of calculation, and I'm not even sure if this is actually correct. Anyway, so at least I've got some practice. So I'll see you guys in the next video. Bye.